you can go ahead through
sir,
concepts
sir.
quickly. You will stop at concepts only when if it is required to dwell on more.
Okay.
Otherwise, you will go ahead with
Okay.
problems.
Anyway, I will give you
Yeah,
example, and it will be good if you just interact with me throughout the session. Okay.
sure, sir. Sure.
Okay, sure, sir.
Right.
Okay. Okay. Fine. So let me share the screen first. I will start from here. Okay. Sorry. Okay. So let me start with Cartesian product. Can anyone just tell me what a Cartesian product is?
May I say?
So
Yeah,
Cartesian.
go ahead.
So the Cartesian product is a it's a combination. It's a type of combination between two sets wherein
Hmm.
each element consists of a pair, where the one element of pair comes from. If there are two sets A and B, then supposing there is the pairs like A B are from, where small a comes from set capital A and small b comes from set capital B, and it is an
Correct.
ordered pair. And
All
Correct.
possible pairs basically.
Exactly. All possible pair. Correct. So if I take suppose two set A is A, B, C. This is very basic. I am starting with, and this is suppose 1 and 2. What is A cross B? Just tell me quickly. So first element will come from A, second element will come from B,
From B.
right? All such pair. Okay. So how many element will be there?
So 3 to
6.
2. 6.
Six element.
Yes, sir.
Okay. Great. So if I can draw this, if I want to see it pictorially, how can we do that? Suppose this is my set A, so there are three, and this is my set B. There are two elements, right? So basically, I can view it like this, right? A related with both of these.
Yes, sir.
Similarly, B related with both of these. All possible relations, right? How I can connect this two set. Right? This is basically your Cartesian product pictorially. Correct? Any doubt till this portion?
no,
No,
sir.
sir.
No. Okay, great. Now, what about relation? What is a relation? So,
The
relation
relation
is
is
basically
wherein
by
we
definition.
combine
Yeah. Yeah, go ahead. Go ahead.
we combine Cartesian product with set comprehension method, and uh, sorry, sir. After that,
Okay,
I
this
just
is not totally correct. Anyone else? What a relation
Relation
is?
is a
What?
subset of a Cartesian product.
Now, what do you mean by subset?
It can be either a comma 1 or a comma 2 or b comma 1. It can be anything.
We
But
replace
orders
So,
are
suppose
important.
Some part is the subset.
yeah, suppose this is a set, my subset is which is inside that set, which can be the whole set also, right? I am not talking about proper subset. Okay, so it can be
Sir,
A itself. Yeah,
relation is a subset of Cartesian project, sir.
exactly. Relation is subset of Cartesian product, just subset, not a proper subset. Okay,
Yes, sir. Yes.
so yeah, correct. So if I have two set A and B as I have taken, now can I say that A cross B is itself a relation?
no,
Is
sir.
it
Yes,
a
sir.
relation?
See?
Yeah.
Yeah.
Yes, sir.
Yes. Okay. The answer is yes. Any doubt till here? Because A cross B is a subset of itself, right?
Right.
Yes. Yes.
Anyone has any doubt in subset and proper subset?
No. No, sir.
No, sir.
No, sir.
Okay. If anyone has any doubt, you can
Sir,
ask me freely.
sir,
Okay, I will spend
sir,
some time
what?
there also. Yeah.
Hello, sir. Am I audible, sir?
Yes. Yes, Ritik.
Sir, what happen if both set are null set?
Both set and null set means they don't have any element, right?
Yes, sir. A and B are empty set, or
So
any one
Cartesian
is
products will
empty
also
set.
have zero element. I mean, no element will be there.
In
Okay.
both cases, if both are empty or any one of the empty set.
Then the Cartesian product will also don't contain any element.
Okay.
Okay. Okay, great. So as you have said, relation is basically a subset. So if I write relation as R is a subset of A cross B. Now,
this is a hello.
yeah,
So this is a proper subset, right? If I take like two elements,
this may
A1
not
and
be a proper subset. That's what I have said. It can be the whole set also. A cross B it itself is a relation. This is what I have written here, right?
okay.
It may not be proper. Okay. Fine.
But sir, but
So
we can take out a proper subset out of this, right?
yeah,
A
yeah,
cross B.
exactly.
Okay.
So subset mean it can be proper or it may not be proper. All are subset, right? The whole set is itself a subset. Okay. So R can be proper subset or A cross B itself. That is what I am saying. Okay, clear? So suppose I am taking in the above example, I am just taking this thing. Will this be a relation? Is it a relation? Is R a relation?
Yes.
Yes, sir.
Yes, sir.
Yes. Okay, great. Because it is a proper subset of A cross B. Okay, fine. And observe that there are two sets, right? We are taking Cartesian product of two set, and the relation we are calling it is a subset of A cross B. So we are dealing with two set. That's why we call this type of relation as binary relation. Okay, bi means two. This means two. So binary relation. Okay, so we will only deal with binary relation in this course for now. Okay.
So I
Sir,
didn't
sir,
understand binary relation.
So binary means we are dealing with two sets, right? A cross B. There are two sets, A and B. And relation we are defining, whatever relation we are defining, that is a subset of A cross B. So there are, R is a subset of Cartesian product of two set, not more than two set. So that's why it is called binary relation.
Binary relation. Thank you, sir.
sir, what if someone asks that C is related to whom? So what would we answer? Is it one or two
So here
or both?
C is related with both. C is related with one and C is related with two. So C is related with both of them.
So,
Okay.
so can we write it randomly?
Yeah, so this is any proper subset. So all possible subset of A cross B will be a relation. Okay.
Okay, sir.
Fine.
Sir, I have one doubt, sir.
Can we say one is related to C also?
So here, yeah, C is related with one, but here which element is coming first? Element from A are coming first. So always we will tell A is related with one, B is related with two. Here one is not related with C because one is not in A. That's in the first place, right? So first element is related with the second element. That's how we say. Okay. Clear?
Yes, sir.
Yes, sir.
Sir, I didn't get it. The relations between functions and Cartesian product.
No, I have not gone till functions here. So Cartesian product is just take this type of pair, first element from the first set, second element from the second set. All such pair will be your Cartesian product, right? And any subset of it, any subset, that will be your relation, right? That is the definition of relation. So any subset of it will be a relation. Clear? Till this portion,
Yes,
is
sir.
it clear?
Yes, sir.
Yes, sir.
Yeah, no, someone
Sir,
who
what
asked
is
this.
the subset here? In this example, what is the subset?
This is the subset. This R. This is a subset of A cross B, right? All elements of here are belongs to here, A cross B. Correct? So it is a subset. Right?
Yes, sir.
Subset means all elements of R should be inside A cross B. So are all elements of R inside A cross B?
Yes, sir.
Yes, sir.
Yes,
But
sir.
let her answer this. Let her answer this.
Sir, some elements are not in that.
Why? Which element is not inside A cross B?
A comma 2.
No, I am saying elements of R should be inside A cross B. So are all the elements of R inside A cross B?
No, sir, I didn't get it.
R should be inside A cross B. So if this is your A cross B, R should be inside that. There
Okay.
can be some element which is in A cross B but may not be in R. That is okay. But all element of R should be inside A cross B. Is this true?
Yes, sir. Yes, sir.
So that is the definition of subset. Clear?
Yes, sir.
Okay, great. Yeah, so now whatever binary relation is called, this is clear to everyone, hopefully. Now suppose I have
Sir,
a single
my
set.
one question is that,
Yeah.
sir, in this whole course, means throughout this whole course, we will always consider 0 in natural number set.
How this is related to this discussion now?
Sir, in set formation, sir, in graded
this is not
question,
related. Anyway, yeah, in this course, natural number includes 0.
So in anywhere, if there is saying that right subset of a natural number and others,
so 0 will be included in natural number. Is that you are asking? Okay.
Sir, I want to ask a question that there was a question of total number of power sets, sir, 2 की power n. In lecture 4, sir explained in lecture 4 sir explained with the n bit number. It was totally which I didn't understand, sir.
I think that was an extra lecture, right? This is not included in the topic, but you just have to know that suppose a set has n cardinality, then the cardinality of its power set, you know what a power set is, that is 2 power n. That only you need to know. Okay?
Okay. It was lecture 4, sir, and at the last he says, sir.
Yeah, so I am saying first don't focus on the proof. If you don't get the proof for this one, it's okay. Okay, but just remember this relation. If A has n number of elements, then power set will have 2 power n number of elements.
There is no need to worry about n-bit theory, sir.
No, for now there is no need to worry about that. If you don't understand it, it's okay, it's fine. You will understand it later.
Thank you.
But do we need to cover extra things like degrees at infinity and?
No. No need to worry about that for now. Okay. First, you clarify your basic concept, then you will go further.
Okay. Sir, please describe the function, sir.
Yeah, I am coming to that, but it will take time. I will come to that. Okay.
At certain degree of infinity will also be covered here.
No, that is not needed for the course. Okay, those who are extra lecture who are interested, they can go through that.
Sir, means,
sir, one request, sir.
Can we? That question will not come.
So first of all, when I was starting this session, I said that if I want to clarify the concept, then let me focus on the concept. Then I will take your question at the end. Will that be okay?
Yes, sir. And primarily, sir, if we can focus on relations and functions, that is where all
that
majority
is what
of
I was trying to do.
Yes, sir. 2 to 3 sessions have gone.
Yes, sir.
Yeah.
All many basic things
this
are
function
covered
is
in.
only for relation and function, sir.
Yes, sir. So
yes, sir. Even in the morning, like we can only discuss relation, and then like we could not come up to function, and then we have to submit assignment by Wednesday. So if we can focus.
Yeah. So I will. So if you don't ask some admin type of question, what will come in quiz, then I think I can cover. Okay.
Yes, sir.
They will cooperate.
Great. So now suppose I have a set A. Okay. It has some element like say 1, 2, 3, 4, 5. I am considering A cross A. Okay. How many element will be there?
5.
What is the cardinality of A cross A?
25.
25. Okay.
25.
Right.
25.
Great. So now if I have this set 1, 1, 1, 3, 2, 4, 3, 4, 5, 4. Okay. Is this a relation?
Yes.
Right?
Yes,
all
sir.
elements are coming from A cross A, right?
Yes,
so R
yes.
is a relation. Yes, okay, fine. Now, suppose I have, so now relation, there are 3 types of relation basically. First is reflexive. What is reflexive? This
It was identity, sir.
not exactly identity, but suppose R is subset of A cross A, then all this A comma A should be inside R for all A belongs to A. What does this symbol mean? So if I have a relation like this, 1 comma 1, 2 comma 2, 2 comma 3 can be there, 3 comma 3, 4 comma 4, 5 comma 5, say 4 comma 5, say 1 comma 4. Suppose I am taking this relation. Is this reflexive?
Yes, sir.
Yes, sir.
Yes,
Can
sir.
someone explain
Yes,
why?
Yes, sir.
Sir,
Yes,
because
because
reflexive
every
relations should have identity relations, identity relation
So,
included in it. It can
huh,
have some other pairs, but
because
exactly.
every element is mapped to itself, right?
So there are 5 elements inside A. So all this 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5 should be there. There can be other elements also. That does not matter. Okay. This is there, this is there, this is there, this is there, and 5 comma 5 is there. There may be some other element also. That does not matter. This is a reflexive relation. Is it clear?
Sir,
Yes, sir.
if there was only like one and one element in this
Huh.
set, then they would call it reflexive in that
Now
scenario.
suppose, let me ask you that question. Suppose I have this. Is this reflexive?
No, sir.
What do you think?
Yes. Yes, sir.
No, it is
Yes,
not.
sir.
No, it is not. It is not. All such pairs should be there. All 1 comma 1, 2 comma 3, 4 3, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5. All 5 should be there. Otherwise, it is not a reflexive relation. Is it clear?
Yes, sir.
It is for all A.
Yes.
Okay?
So,
This is very important here.
sir,
Please scroll up.
if there is 3 comma 3 and 2 comma 3, then it will be reflexive.
Yes.
For reflexive, all this should be there. All this. And whatever other element is there, it is okay, fine.
5 also need.
Every 1 comma 1, 2 comma 3, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5.
Every
All 5
identity
should be there. Huh?
Yes, sir.
Every identity should be there, sir.
Every identity should be there.
Should be there.
There can be some other element also, but at least those 5 elements should be there.
Okay.
Sir, what is
Clear?
identity here?
Identity means he is just referring to this 1 comma 1, 2 comma 2. These are identity. Okay. A comma A pair, he is calling that identity. Okay. Is it clear?
Means both should be same.
Yes.
Both are same. All such pairs should be there. Clear?
Yes, sir.
So reflexive relation is clear to everyone?
Yes, sir.
Sir.
Okay.
Yes, sir.
Yes, sir.
Fine. Now the second is symmetric relation. Symmetric relation. What is symmetric relation? It is saying, follow this statement properly, okay? Whenever A comma B is in R, then B comma A must be in R.
to R.
Must be in R, okay? Remember this statement, how I have written it. Whenever A comma B is there, okay? So suppose I take an example again in the same thing, A cross A. So A was 1, 2, 3, 4, 5 was taken. R is a subset of A cross A. Now what R I am taking? Suppose 1 comma 1, 1 comma 2, 2 comma 1, 3 comma 3, 4 comma 3. Is it reflexive? Is it symmetric?
Yes, sir.
Yes, sir.
Is it?
No, sir.
Not
No, sir.
reflexive.
No, sir. No, sir.
Yes, sir. It is
Okay.
symmetric.
Yes,
3,
sir.
comma
It's
4 is
symmetric.
not.
Symmetric, sir.
So 3 comma 4
1 comma
also need
2
full
and 2 comma 1
symmetric.
are there.
Exactly.
No, sir.
Both are there.
No,
Okay,
sir.
so there are two type of answer I am getting. One of
So
you,
it is
one-
reflective, sir.
Yeah, so one group is saying it is symmetric, one group is saying it is not symmetric, right? So what I am saying, whenever A comma B is in R, B comma A should also be in R, right?
Yes.
Let's start with the first element, 1 comma 1.
Yes.
So if I interchange the position, what will be the element?
1,
1 comma 1 itself,
1, 1.
right? So no, we don't have to worry about that. That is there. if I take 1, 2, if I interchange the position, what I will get?
2, 1.
2, 1.
Is that inside R?
Yeah. Yes.
So it is inside R. Okay. Now similarly, if 2, was inside R, then if we interchange this, then 1, 2 is also there, right?
Yes, sir.
Okay. For 3, 3, do we have to worry?
No.
If we interchange the position, it is
No.
again 3,
No.
3, so it is inside R.
Yes.
Correct?
But
Okay. For 4, 3, now 4, 3 is inside R, right? Whenever this is
Yes,
inside
sir.
R, if we interchange the position, what I will get?
3,4.
Is it inside R?
Which is not there.
No.
There.
So it is not symmetric.
Okay.
Clear?
Okay.
Yes, sir.
Yes.
Yes, sir.
I am giving you another example. Okay. Is it symmetric?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So for 1, 1, we don't have to worry. For 1, 3, 3, 1 is
3,
also there.
1.
Also here. Yes, sir.
These two are same. For 3, 4,
4,
this one,
3.
4,
Then 4,
3 is
3 is also here.
so it is symmetric, right? And there are no other element. So it is symmetric. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay.
Sir, will we not deal with element 5 in this scenario? Element 5.
It may not be, no. It may not be inside your set, inside your relation. It may not be. That can happen. Right?
So minimum we are dealing with 4 elements, right? If this set
that can happen. That is a subset. That is a subset. It can also just dealing with 1 and 2. That is also possible. Okay.
Okay.
Sir, what if there is 5, 3 in that?
Okay, so let's take that. So with this, with all this, I am adding another one, which you are suggesting 5, 3, right? Now, is it symmetric?
No,
sir.
No, sir.
So 3, 5 is not there.
3, 5 is not there, correct? 3, 5 is not there
Not
for
there.
this one. So it is not symmetric. Clear?
Yes, sir.
Yes.
Everybody understood this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
great. Great. Now, what is the next one? Third one?
Transitive.
Okay. Let's understand transitivity. Again, follow what I am writing. Whenever A,
Hello,
comma
sir.
B. Yeah.
Sir, I have a question.
About which thing?
Sir, 1, 1, 2, 2, or 3, 3 is symmetric relation.
So you answer me that. Suppose I have 1, 1, 2, 3, 2, 2, 3, 3. Is it symmetric?
Yes, sir.
Yeah.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Why?
It is symmetric.
It
Yes,
is
sir.
reflexive,
We had both.
symmetric, and transitive.
So because
If we
both
interchange
elements are
If we interchange the position, we get the
They're
same thing and that
same,
is inside R. Right?
But not reflexive.
It is not reflexive. Great. Because? Because?
4, and 5, 5 is not here.
Exactly. Fine.
Okay.
So this is yes. For reflexive, this is no. Okay?
Sir, are
Yes,
all
sir.
identical, reflexive and symmetric?
All identical are reflexive and symmetric. Correct.
अच्छा हम बाद में कॉल करो कभी रख काट कर.
If you are not saying something here in the class, then you should probably mute yourself. Okay?
Sir, I have doubt.
Yeah.
Sir, in above example, we take 1, 2, 3, 4, 5. Instead of these, if we take 0, 0, then it will be symmetric or not?
Where?
In this all, we take A is equals to 1, 2, 3, 4, 5.
Okay.
Instead of 1, 2, 3, 4, 5, we take suppose 0, 1, 2, 3, 4, 5.
3, 4, 5.
And
Okay.
and if we multiply A into A, then we get 0, 0. Then 0, 0 will be symmetric or not?
No, symmetricity counts for a set, not for a single element, right?
After.
So let me write what you are saying. Let me write it, okay? You can work with me. So you are saying my A, let me call it B. Okay. 0, 1, 2, 3, 4, 5. Okay. Now you have B cross B. You know what are these. R will be a subset of this. What is your R? Can you tell me?
0, comma 0.
Okay.
1,
0, comma
1.
0. 1, comma 1. 2,
Okay.
comma 2.
Okay.
Then this will be symmetric or not? In this
No.
case, 0 will be. In this case, 0, comma 0 will be symmetric or not?
Not one element. We are not talking about a single element. You can ask, is R symmetric or not? Right? Because R is your relation.
Okay.
Right? Now,
Then
can
R
you tell
contain.
me?
Then R contain all elements like 0, comma 0, 1, comma 1, 2, comma 2, 3, comma 3, or 4, comma 4, 5, comma 5.
It may contain or it may
All
not
relations.
contain. R can be any subset of this. Now you have chosen this subset, right? R can be any
Yes.
subset, okay? Whatever combination I need from this B cross B, okay? Whatever subset I can choose. Now you have chosen this subset. Now tell me, is it symmetric or not? Is this R symmetric?
Yes.
Yes, sir.
Yes, sir.
Yeah,
Yes,
let
no,
her
sir.
answer this.
Sir, I am confused here because 0, comma 0.
Why 0, 0? This is a single, this is another element like 1, 2, and 3. These are just symbols.
Sir, it is
Sir,
symmetric.
it is reflexive as
If
well.
you change, one minute, if you interchange the position inside this 0, 0, what you will get?
0, comma 0.
0, 0.
So that is inside R, right?
Yeah.
The same thing. I mean, here 0 does not actually giving some different
Value.
value to the problem, right? This is just a symbol.
Yes.
0, 1, 2, all these are symbols. Instead of number, you can take A, B, C, D also like that. And you can define the relation like that.
Not an integer.
Okay, sir.
Yeah.
Yes, sir.
Okay. So this is a symmetric relation.
Thank
Because
you, sir.
whenever A, comma B is there, B, comma A is also there. Because whatever you have chosen, that is same for A, comma B. If you interchange the position, we will get the same element, right? And that is inside R. Clear?
Yes, sir. Clear, sir.
Yes, sir.
Okay,
Next
great.
example.
So I will go to transitivity. Now, transitive relation.
Sir, I have one doubt.
Okay.
So in the before example, the 0, 0, 1, 1, and 2, 2. So that is this range, this set is symmetric as well as reflexive as well.
No, it is not reflexive. Why it is reflexive? 3, 3 is not there, 4, 4 is not there,
Yeah, yeah.
5, 5 is not there. So it is not reflexive.
Yeah, got it, sir. Thank you.
Got it, no?
Yeah.
Okay, great. Transitive relation. Whenever A, comma B and B, comma C are in R, both are in R, then A, comma C must be in R. Okay? Whenever these both are in R, so let me write it in word. Okay. What is this saying? Suppose I am taking again the same thing. A is my 1, 2, 3, 4, 5. Now, suppose I am writing this element. Okay. This is a relation. Whatever I have taken R, this is a subset of A cross A. Correct?
Yes, sir.
This is a relation, right? Okay. Now my question is R a transitive relation?
Yes,
What
sir.
does transitive
Yes.
relation?
Yes, sir.
What,
Yes, it is
sir?
transitive.
Okay.
Yes. Yes, sir.
So what is it doing? Suppose I am taking the first element 1, 1.
Sir,
This.
can you explain transitive relation?
Yeah, that is what I am doing.
Sir, from starting, sir.
That is what I am doing. Just follow from here, you will get that. Okay. Suppose I am starting with the
Okay,
first
sir.
element 1, 1. Okay. And taking the second element 1, 2. This is my A, this is my B, this is my B, this is my C. Okay. I am taking two elements where the second element of the first pair and the first element of the second pair are same. This should be there. If such case happen, if these two belongs to R, then A, C should belongs to R. Right? Then from the first two, which element should belongs to R?
1 and 2.
1 and 2.
1 comma 2 belongs to R. Is that belongs to R? Yeah, that is there.
Yes,
Right?
sir.
Okay. Now for second and say this one, 1 comma 2 and 2 comma 3. If I take these two belongs to R, then from these two, which element should belong to R?
1 and
1
3.
comma 3.
1 and 3.
Because this is the second element of the first one, this is the
Yes,
first
sir.
element of the second one. So this comma this should be inside R. Right? So this is there. Correct?
Yes, sir.
Now, if I take 2 comma 3, is there any element starting with 3?
No.
No, sir.
No. So we don't have to check.
No, sir.
So we don't have to check for that. Because we need this condition to be satisfied first. Okay? We should have two elements for which the second element of the first pair and the first element of the second pair should be same. Then only we can check. Otherwise, we don't have to check. Okay? Now, so
Yes, sir,
for
yes,
the
sir.
third element, we don't have to check anything. For the fourth element also, is there any element which is starting with 3?
No, sir.
No, so we don't have to check. Now, whenever this type of element, I mean, where the second element of the first pair and first element of the second pair are there, then A comma C are inside this R, right? That what we got, these two, right? So is R transitive?
Yes, sir.
Yes, sir.
Is it clear to everyone? We'll take another example, don't worry. But
Yes, yes. Yes, sir.
for this example, is it clear?
Yes, yes. Yes.
Okay. Okay. I will take another example. Okay. Suppose 1 comma 2, 2 comma 3, 3 comma 1, 1 comma 3. We can work with this. Okay. So first, to take two element, 1 comma 2 and 2 comma 3. So first element of the second element of the first pair and first element of the second pair are same for the first two. Which element should be there?
1 comma 3.
3.
It is there, right? So this
Yes.
is okay. Now, is there any element starting with 3?
Yes.
Yes, sir.
Yes. So we have to check for
3,
that. So we have to check for that. Now, for this, which element should be there?
2
2 and 1.
1. 2, 1.
Is it inside R?
No.
sir.
No, sir.
So it is not
Not
transitive.
No.
Sir, if there is not that fourth element is there, should we call this a transitive relation?
Fourth element means?
1 comma 3. If it is not there.
Then also, I mean, whenever you will get some element which is not there, like A comma C, then we will call, I mean, this is not transitive. That's what we are doing, no?
Okay.
We have to find just one.
So for the first two pair, if we take the first two pair, as you can see, 1 comma 3 should be there, and it is there, right? It is there. But when we are checking for these two elements, then we are not getting 2 comma 1 inside R, right? But it should be inside R to be transitive, right? So it is not transitive. Is it clear?
Sir, I didn't get the non-transitive part. That why 2 comma 1 not belong to that part.
Is 2 comma 1 belongs to R? First tell me that. Is 2 comma 1 inside R, whatever R I have written?
No.
No, sir.
But this is your A, this is your B, this is your B, this is your C. For transitive, whenever A comma B and B comma C are inside R, A comma C should be inside R, must be inside
Yes,
R.
sir. Yes, sir.
But it is not, right?
Yes, sir. Okay.
Got it?
Yes, I got it. Thank you, sir.
Is not inside R.
Sir, hello.
Yeah.
Sorry, I'd like to. Sorry, I have a doubt. So does it mean that all the elements, even if there is one element which is not an element of R, then the whole set is not transitive, is it?
If A comma B and B comma C, these type of element are inside R, then whenever I am getting some element A comma C which should be inside R but it is not, then we will call it not transitive.
The whole set is not transitive. Okay.
Yeah. Right? Now, suppose I am adding one more element with this set. Let's go deeper in this thing. So 1 comma 2, 2 comma 3, this was there. 3, 1, 1, 3. Now I am adding 2, 1, right? So these 4 element, what was earlier, I am adding one more element, 2, 1. Now is R transitive?
No, sir.
No, sir.
Why? Can someone tell me?
3,
No,
3 is
sir.
not there.
Because there is no one.
No, sir. There is no one more
Ah.
variable for that.
So again, I will discuss from the beginning so that everyone should understood. Now I am getting much noise from your side. So I am just mute everyone and then you can call. Okay. Yeah. So let's start from a beginning. 1, 2, 2, 3. For this type of element, which should be there? 1, 3, which is inside R. Correct. We got this. Right? This 2 is common. 2, 3, 3, 1. What type of element should be there?
2, 1.
2, 1. Is it inside R?
Yes. Yes, sir.
Is there, right? So these 2 are okay. Now, for 3, 1, is there any element starting with 1?
Yes, sir.
Comma 3.
1, 3.
1, 3. Now, which element should be inside R for this?
3,
3,
3,
But sir,
but it
both
is
are
not, right?
Yes.
So it's
But not. Yes, sir.
It is
Not
not
there.
transitive. Clear?
Yes, sir.
Sir, 1, 1 also is not there.
Yeah, right. Again, for the next one, 1, 1. I mean, 1, 3 is there. This element, 1, 3. 3, 1 is there. So this is common. Now, 1, 1 is also not there. Right? So there are all such. Again, 2, 1 is also needed, I think. Right? Sorry,
2, 1, 2 is also
needed.
So it's neither that.
2 is also needed.
Sir,
Right?
sir, we did the same thing in the first example, and that was transitive. So can we go to that first example which you showed?
Yeah, right. This was the first example.
Yeah, 2 elements were satisfying this condition, right?
Because there are no other elements to check. There are no elements left for which A, B and B, C type of element are there. There are no elements starting with 3. There are no elements starting with, 2 for we check. Elements starting with 1 also we have checked. So there are no elements starting with 3. So we need to check for.
Voice is breaking. Possible to check with 1, 2 and 1, 3?
Is it?
Is it possible to check 1, 2 and 1, 3?
You tell me, is it A, B and B, C type of element?
No, sir.
These 2 are not common, right? These 2 should be equal. There are no such element left, right? That's why it was transitive.
1, 1 and 1, 3 is possible, right?
1, 1, 3 is possible. Exactly. 1,
So
1.
it's okay if it gives, 1, 1, 3 gives 1, 3 itself. So is it okay?
It is okay, no? Yeah. I mean, whatever is coming. So this was transitive. That's what we have checked, no? This was transitive.
Okay.
So then first example.
In this set, sir, 2, 3.
1 by 2.
Sir, can we please explain first example how does it is symmetric transitive?
Just now I have explained this, right? So let me take another example, okay? For that
So is it okay to write only few elements from R, or is we have to write all the five numbers you gave, right? So 1, 2,
R
3,
will be
4.
given, right? Whatever R is coming, R will be given, right? And you have to check with only those numbers.
A is 1, 2, 5, right? 1, 2, 3, 4, 5. So
But R is just subset of that.
Okay.
Right?
So
And you have to check with only with R. Now your focus will be only with R, whatever the pairs are. Right?
Okay.
Got it, no? If there is no 2, 5, you don't have to bother about that.
Okay.
Is that what you are asking?
Yes, sir.
Okay, great.
Hello, sir.
Yeah.
Sir, if suppose there are 2 pairs A, B and B, C, and we make a pair A, C, then we call it transitive. If suppose it's in the reverse order C, A, then also it will be transitive.
No.
A, B and B, C will make
no. Whenever this type of element, some element is there, A, some element is there, which is B, this first element is the same with the first one, and C, this type of element there, then you have to check whether A comma C is there or not. Now
Okay,
this
and
should
the
happen for
reverse
all
C,
such pair.
C comma A is not true. If
No.
C comma is there, is
That
a
doesn't
pair.
matter actually. That does
Okay.
not matter. Okay. Let me take another example. Okay. Then I think you will get. Tell me, is it transitive or not?
Transitive, sir.
No, sir.
Yes, transitive.
No, sir. No, sir.
Okay, so many of you are saying no, many of you are saying yes.
2, 3 is not
Transitive.
Sir,
Not
2,
transitive.
3 are not same.
Transitive.
Sir,
Sir, it is
transitive.
transitive.
1 comma
Cannot
2
be
it is
checked.
because there is
No.
no
Okay, let me explain this. Okay, fine. Let me explain this. So what type of pair we need? We need, suppose 1 comma 2, then is there any element starting with 2?
No.
sir.
No, right? So there is nothing to check for this element,
Transitive.
right? Is there any element starting with 3?
No.
No, sir.
Is there any element ending with 1? Because there are elements
No.
starting with 1, right? Is there any element ending
No,
with
sir.
1? No.
Sir,
So we don't have any two pair. 1 minute. We don't have any two pair for which this happens, right? For which this happens. We don't have any such pair.
Yes,
Right?
sir.
So we don't need A comma C inside this because we don't have these two pair to begin with. Right? Remember what the definition I have written for transitivity. Whenever this happens, then this must be there. But if those A comma B and B comma C are not there, then I don't have anything to check. So it is obviously transitive because we don't have any such element.
Sir, but
Sir,
for a
please explain
transitive,
again.
don't we need at least 3 elements in that?
No, that is not necessary. Okay.
Sir,
So
in the
what I am saying, I am explaining it again. Whenever I have two pairs for which, let me finish, then I think I can again take your doubt. So whenever I have two pair for which the second element of the first pair and the first element of the second pair is same, then the condition is then it should be there, right? Then A comma C should be there. Now in this set, in this R, I don't have any such two pair. I don't have any pair starting with 2. I don't have any pair starting with 3. I don't have any pair ending with 1. So I don't have to check for this argument, right? My argument is vacuously satisfied. I don't have any pair to check, right? So whenever I don't have, then obviously I can say it is transitive, right? Because I don't have any such pair.
So why
It means, sir, end condition is not fulfilled here.
Because I don't have any such pair. Transitivity is saying whenever I have this type of pair, then this should happen. Now here, to begin with, I don't have this type of pair. So I don't know what is A comma C. I don't have to get that pair, right?
Suppose if there is 3 or 4 element in that relation, but we don't get a pair like that.
Exactly. Then you can directly say it is transitive.
Then also it could be transitive.
Exactly. Now suppose, let me do it further. Now suppose I have this. Now can you tell me, is it transitive or not? Is it transitive?
Yes, sir.
Yes, sir, it is transitive.
For which element you are checking?
Yes, sir.
Yes,
1
sir.
comma
2.
then 1 2.
1 comma 2.
So first of all, for 1 comma 2, we don't have any such pair B comma
2
C because there are no element starting with 2, right? So that
Yes,
is
sir.
not there. But for 1 comma 3, we have another element 3 comma 2
3
starting
comma
with
2.
3.
Yes, sir.
Right? So 1 comma 3 and 3 comma 2. Which element should be there?
There must be
1
1 comma
2.
2.
Must be there.
TBBC.
1 comma 2.
1 comma 2 must be there. I mean, this is really irritating. Yeah. So what I am saying, 1 comma 2 must be there. Is it there?
Yes, sir.
Yes,
It
sir.
is there.
Yes, sir.
Is there any such pair? for which we have to check any such this type of pair?
No, sir.
Are there anything
No,
left?
sir. No, sir. It's just 1,2.
There are nothing left, right? We have checked everything. So there are only such pair A comma B and B comma C for which I have taken A comma C in my account, and it is inside R, so I can say it is transitive. Is it clear to everyone?
Yes, sir. So
Yes,
for
sir.
transitive, we can say minimum 3 pairs are needed.
No, this is what I have said. I have given you an example of transitive relation where we don't need 3 elements. I mean 3 pair.
But minimum, sir, minimum.
There are 2. 2 is less than 3, so 3 is not minimum. Right? How many
Then-
pairs are there inside R?
Then C comma A.
No, just answer this question. How many pairs are inside R?
2.
I want an answer from him.
There are 2.
There are 2. So this is transitive, right? This R is transitive, right?
There
have
is
checked, no?
needed A comma C.
Again, you are saying that thing. I don't need A comma C always. If I have A comma B and B comma C, then only we need A comma C. If we don't have A comma B and B comma C, why should we need A comma C?
Yes, sir.
Right?
Sir,
So
is
there
null-
can be some relation which is less than 3 element, which has less than 3 pair, but still it can be transitive. Okay? I have given you the example.
So,
Yes,
sir,
yeah.
is a null set transitive?
Null set is everything. I mean, only it is not reflexive.
Only
but
one pair is.
It is not
If only
reflexive.
one pair is there, if so, can we call it transitive? If only one pair is there.
Yeah. Now I will ask you that question. Suppose this is my set. I am giving you only this pair. Is it transitive?
Yes, sir.
Yes, sir.
Yes, sir, it
It is
is.
transitive because there is
Yes, sir.
no A, B comma C
Yes, sir.
for which we check. Transitive. Okay. Now this is yes. Now next question. So this is just to know whether you have understood this relation or not. 1 comma 2, 2 comma 3, 1 comma 3, 1 comma 1, 2 comma 1 is reflexive. First tell me whether it is reflexive or not.
No, sir.
No, sir.
No, sir.
Why?
No, sir.
Why?
It does not contain all the
Every pair should be
Or
there.
some
1, 1, 2.
elements are not reflected.
Yes, sir. Some of them are not replicative.
2 comma 3.
2
Okay.
comma 2 total.
So basically 1 comma 1 is there, but 2 comma 2 and 3 comma 3 are not there, right?
Yes, sir.
Yes.
Sir, please mute everyone, please.
That's what I am doing, but you should also behave like that. Okay, so is R reflexive? No, the answer is no, right? Because 2 comma 2 and 3 comma 3 is not there, right?
Yes, sir.
Okay, is R symmetric?
No.
No, sir.
No, sir.
Which elements are not there?
1 comma 3 is there, but 3 comma 1 is
2 comma
there.
3.
3 comma 2.
Exactly. So 1 comma 2, 2 comma 1 is there. That's okay. That's fine.
Comma
For
3 is
2
not
comma
there.
3,
3 comma
3
2
comma
is
2
not
is not
3,
there.
comma 2 and 3, comma 1.
3 comma 1 is also not there.
Also for
Exactly.
1
3,
comma
comma 1
That
is
is
also.
no. Yeah, right. Now what about transitivity?
No, sir.
Which
No.
element is not there?
1 comma
2 comma 2 is not there.
2
2 comma 1 is
Ah.
there. 1 comma 2 is there, but 2 comma 2 is not there.
Right. So if you check for first 2 element, let's say for first 2 element, 1 comma 2 and 2 comma 3. 1 comma 3 is there, right? This is there.
Yes, sir.
Okay. Any element starting with 3? No, right?
No, sir.
No, sir. So it's not there.
So these 2 are gone. Any element starting with 1? It is
Yes.
there, right? This
1
One.
comma 2, sir.
Yes, sir.
So 1 comma 1 take 1 comma 1 and 1 comma 3. What should be there?
1 comma 3.
1 comma 3.
1 comma 3. That is there. That is okay. That is fine.
Yes, sir.
1 comma 1 and 1 comma 2. Which element should be there?
1 comma 2, sir.
1 comma 2. That is also there. That is also there. 1
Yes,
comma
sir.
2 is there.
Yes, sir.
But now this one, take this one. 2 comma 1 and 1 comma 2. If I take these 2 pair, this is ending with 1, this is starting with 1. What element should be there?
2 comma 2, sir.
But is it there?
No,
No, sir. It's not there.
It is not there, right? So this is also no. So this is a relation which is neither reflexive, nor symmetric, nor transitive.
Neither transitive.
Okay, in not any one of those. Okay.
Yes, sir.
So,
Yeah.
sir, sorry to interrupt, but will we be discussing about the practice questions in this session?
So I asked in the beginning. So today we are planning to discuss first about the relation and function. Then I will go to questions separately.
Yeah, sure.
Okay?
Thank you, sir.
Okay.
Sir,
Fine. Yeah.
sir, there is a book shared with us on week 1, and in that example of transitive, there is a relation given which is not transitive, but that book mentions it as transitive relation.
What is that relation? Can you tell me?
Sir, it is defined on set
அந்த டிக்கெட் போட்டு
1,
நான்
2,
அதுக்கு
3,
நான்
4.
பண்ணியிருக்கேன் மற்றது பண்ணணும் ஆமா
Yeah, tell me.
Sir, it's defined on the set 1, 2, 3, 4, and the relation
Okay.
is 2, 1.
1 minute. Let me write it.
இன்னிலேருந்து தான் போடணும் முதன்
Santosh, can you mute yourself?
I'm so sorry.
And the relation is 2, 4, 1, 2, 1, 4, 4, 1, 1, 1, and 2, 1.
Okay.
That's it. And it is mentioned that it is a transitive relation. But since 2, 1 is there, and 1, 2 is there, but 2, 2 is not there, so it's
So it is not transitive. Yeah, correct. You are correct.
There is a
It is not
mistake.
transitive. Yeah, it is mistake. You can mention it in the forum. They will correct it. Okay.
Okay. Thank you, sir.
Okay, fine. So this is not transitive. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes.
Why? Why?
So because
So here already mentioned this
2,
2, 1 and 1, 2 if we take
2, 2 doesn't exist.
2, 2 is not there. Great. Correct. So I hope you have understand what is reflexive, symmetric, and transitive, right?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, sorry, there is one basic doubt I have. All these transitive, symmetric, and reflexive definitions apply only to R, isn't it? They don't apply to A. It's only
Because
to the
they are
Cartesian
relation.
products.
Relation is basically talking about pairs. A is just a set.
Okay.
Right? Okay, great.
I didn't get the third condition, 2, 1, 1, 2, and 2, 2 is not there. So it is not reflexive.
Not transitive.
Okay. So it is not transitive. So
Not transitive.
above two conditions are satisfying the criteria, and one condition is not satisfying the criteria. So this
No, what you are saying? I am saying whenever.
why it is not transitive. Like
No,
two
what?
conditions are satisfying the criteria, and third one is not satisfying the criteria. So it is not transitive.
Yeah, so basically what is there? So this is my element of A comma B and B comma C, right? This is my A, this is B, and this is C. So according to the definition of transitivity, 2, 2 should be there, right?
Yes.
But it is not. That's why it is not transitive. Clear?
If 2, 2 was there, then it would be transitive.
Then you have to check for any other element are there or not. I mean, there may be any
4,
other element for
4,
which it is not.
4, 4 is not there.
Yeah, right. So suppose I am adding 2, 2 here. Let's say we are adding 2, 2. Still it is not transitive, right? Because we have these two pair, 4, 1 and 1, 4. That should imply 4, 4 should be there, but it is not.
Sir,
Again,
can we take that first pair 1, 2 and then 2, 1?
Then 1, 1 is there. That is okay. But
Then
still, there are some such pair for which this is not satisfying. That is enough, right?
So we need to
check for all.
Check
for all
all
possibilities. Exactly.
and then all must be transitive.
Sir, it need not be sequential, right? So it need not be like continuous, like next to next set. We don't have to compare. It can be anywhere.
It can be anywhere, right?
Okay.
Right.
Just that we need to find if we
So I
have.
will tell the relation
Exactly.
is
Exactly. Yeah. So Yeah.
So there is a activity example. I can tell you. Wait, give me a second. Just to tell you.
I will come to
That
activity later.
activity.
Okay.
One
I will
point
come to
that
activity question later.
it's related to that transitive.
Okay. But it will
1.10
delay the
and
discussion of function. I wanted to finish that discussion and then come back to your question. Will that be
Yes,
okay?
Okay,
sir.
okay,
We
okay.
need a function.
Okay.
We need
Yes, sir.
function.
We need two functions.
Okay.
Okay.
Sir, is
So
null
first,
set
Sir, I will take the
identity relation?
whether it's
one by
positive or
one, one by
not.
one. What?
Sir, is null set a identity relation?
I mean, why all of you are bothering about null set? Null set is a set which does not have any element, right? And how null set can be an element? I mean, relation. You have to define null set cross null set. Then your relation is again a null set. Then obviously it satisfies all those things. So it is obviously a. I mean, it is symmetric, reflexive, anything. It is vacuously satisfied. I mean, no elements are there, so you don't have to check anything, right?
Okay.
If your relation is on a null set, but if you have started with suppose this set 1 comma 2 and your relation is a null set, this is your relation null set, okay, then tell me, is it reflexive? Is R reflexive?
No.
No.
Why?
1 comma 1 and 2 comma 2 is not here.
At least 1 comma 1 and 2 comma 2 should be there, so it is not reflexive, right?
Yes.
Is it symmetric?
Yes.
It is symmetric, right? Because what symmetricity said? If A comma B is there, then B comma A should be there. Now there is no A comma B because this is null set. No elements are there. So it is symmetric.
Sorry,
R is symmetric.
sir, when you're talking about reflexive, should it contain both 1 comma 1 and 2 comma 2? Or
exactly. Both.
So for set A, the relation R should contain the reflexive relation for every element of A.
Exactly. That's what I have written in the beginning.
Okay.
Why are
Sorry,
you present
sorry.
there?
Yeah, sorry, I was not there in the beginning. Sorry. That's why I asked.
No, it is there. I have written this. Okay. So
Thank you.
this is where I have written for all A.
Thank you. Sorry to delay you.
Okay.
Thanks.
Yeah, no issue. Okay. So for null set, is it symmetric? Who was asking this question? I forgot her name.
Sir, I was asking.
Yeah, Kavita. Is R symmetric?
Yes, sir.
Why?
But A and B is not there.
I mean, any pair is not there, so we don't have to check for the opposite
For
pair,
other
right?
things.
Yeah.
Okay.
Is
And
it symmetric? Hey, transitive?
transitive, yes, sir, because
That is
again,
so it is
A
both symmetric and transitive, but it is not
and not
reflexive.
reflexive and identity.
Clear?
Okay, sir, got it.
Okay, sir. If set A was a null set, then if
then it is everything.
Okay.
Sir, just
Then it
one
is
question.
Yeah.
That it mentioned that for what is the minimum number of element Cartesian product have that such that relation becomes systematic. So symmetric. There is mentioned that at least 3 elements must be there in an
No, that
activity
depends.
question.
That depends. Where have you find this question?
I found that question in activity 1.10 8th question.
Okay, let me open it. Which one? Activity
1.10.
Activity 1.10. Okay, let me open this. Which question?
8th question.
8th question. What is the minimum number of elements in the Cartesian product is need to be added to R such that the relation becomes symmetric. Added to R. So here one R is given. Already an R is given. With this, what more you need to make it symmetric? Okay.
So we are talking
can you see the
about
difference
that
between what
relation.
you have just said and this question?
That relation is given over there.
Here already a relation is
That
given.
here-
Now you have to add some elements so that it becomes symmetric. Now snail frog is there, but frog snail is there.
Yeah.
Where?
No. Sorry.
No. So you have to add that,
Basically,
right? You have to add that.
Okay.
Correct? Bird is there. So
And
if
the
you change the
second-
position, this is the same element. Correct?
And second thing is that in that question that
No, first
you
of all,
mentioned.
let me complete this discussion. I mean, have you got why three elements is needed?
Yeah.
Why?
There is not. Can you again ask that question? What you asked?
So how many elements should we add to make it symmetric? So snail frog is
Three
there,
more
but
elements.
frog snail is not there, right? So you have to add that.
Yeah.
Bird we don't have to bother because if you interchange it will be the same. Fox frog, if we interchange fox should be there, it is not, so you have to add it. Snail fox, so if you interchange it, fox snail should be there. So you have to add 3 more elements to make it symmetric.
3 more elements there. Okay.
Okay. So okay. Now when a relation is all this together, reflexive, symmetric, and transitive, what is it called? All this together.
Equivalence. Equivalence relation.
Okay. Okay. So for now, I am not going deeper in this relation thing. I just move to function because that's what we need. Then I will again come back to this. Okay.
Sir, equivalence class.
Equivalence class is different thing. First, you understand what is equivalent relation. Then I will come to equivalence class. Okay. I am not going to that part now. Okay. Now let me go to function because that will be very much needed. Okay. Is it okay?
Yes, sir.
Yes, sir. Yes, sir. Fine. So let's start with this set again. I am taking this first, what I have started with. Okay. Now, a relation when I am defining it like, so suppose this relation 1 to 1, 2, 4.
Sir, it is example of equivalence relation.
Which one?
It's example of equivalence relation.
Which one? This one?
Yes, sir.
No. I am not giving that.
Okay.
Okay. Equivalence relation means it has to be all reflexive, symmetric, and transitive. But
Yes,
as you
sir.
can see, this is not reflexive, right? So it is not an equivalence, clearly.
Okay, sir.
Okay. But I wanted to mention something else. So this is A cross A, right? This relation is from A cross A. So this is my A, this is my A. Here I have 1. So you remember how I draw the pictorial representation of A cross A or A cross B. I will doing the same for here. So this is 1, 2, 3, 4, 5. Okay. So 1, 2. This, right? 1, 4. This, correct? 2, 4. This. And 3, 5. Sorry. This. Correct? This is the pictorial representation of R. This is my R. Right? So I can draw something like this. I can represent my relation pictorially like this. Correct? Now, when I am talking about function is one type of relation. Why I am saying that? So I will come to this statement later, but first understand what is a function. So suppose I have 2 sets, A and B. Okay, I have 2 sets. Now function, you can think it as a machine. What does this machine do? It will take some input and it will give you some output. Okay. Suppose I am giving you the function x square. Okay, this is my function. So how it works? If I give you 1, what is your output?
1.
If I give you 2, what is your output?
4. The 4.
If I give you if I give you 5 by 2, what is your output?
25 by 4.
5 by 2.
25 by 4.
25 by 4.
25 by 4.
Okay. If I give you -3, what is your output?
9.
9.
9. So
Please
you
mute
are,
disturbance.
Please mute, sir.
Everyone
To all, sir.
mute yourself.
I am requesting those who are not talking and those who are in some noisy condition, please mute yourself, okay? Otherwise it is really irritating.
Yes,
Okay,
sir.
so what it is doing, we are taking some input and we are finding some output. That's what a function does. Okay. Now coming, so this is the vague definition of function. It will take some input, it will give you some output, right? This you can remember, right? Now, what is the mathematical formation of this picture? What we can do here? So suppose the mathematical definition, what we do, suppose I have two sets, A and B. Here I have 1, 2, 3.
So just one doubt in the what you drew the diagram. The function was shown as square operation, but can it be anything else than
Anything?
operation?
No, I
like,
have just given one operation, one
no,
function.
sir. Can it be a condition like greater than, less than, something like that? Can
No.
that also be?
That
like,
depends on which set you are defining a function.
Okay.
Okay. In some situation, it can be a function, but that depends. Okay, on which set you are defining a function. I will come to that.
Right.
I will come to that question. Okay.
Okay, sir.
Okay. So I have two sets, A and B. What is the function? It will take some element from here and it will give an output here, right, in B. And for each element of A, it should give an output. Okay. What does it mean? 1 is going to somewhere, say 2. 2 is going somewhere, say 3. 3 is going somewhere, say 1. 4 is going somewhere, say 3. 5 is going somewhere, say 5. Okay. This is a function. So what I am getting, 1 is going to 1. Sorry, 1 is going to 2. 2 is going to 3. 3 is going to 1. 4 is going to 3. 5 is going to 5. This is one function. Okay, it is taking some input and giving some output. So two important conditions are there. Every element should be mapped somewhere, right? Every element should be mapped somewhere. I mean, every element should be taken as an input. That is the first condition. Every element should be taken as an input. And the second condition is further more important. One element cannot go to two different outputs. So one input cannot give two different output. Okay. What does it mean? One cannot go, suppose I am taking 1. 1 cannot go to 2 and 3 both. This cannot be for a function. Right? So whenever I am writing a function, so if I want to write it as a set, 1 is going to 2. So first element is my input, second element is my output. 2 is going to 3. First element is my input, second is my output. 3 is going to 1, 4 is going to 3, 5 is going to 5. So this is a function. Correct? This is a function. But if I write this thing, I take a relation. And say 5, 5. This is a relation, right? On A cross A.
Yes, sir.
Yes, sir.
This is a relation, but is this a function?
No, sir.
No, sir.
Why?
Because 2,
Because 1 is
3 and
related to
4,
2 and 4.
2 and 4 are on 3. Sir,
Sir.
1, 2 and 1, 4.
No.
One
So
can
1 is going
Sir.
to two different elements.
So you are
Don't-
telling that 2 and 3 cannot be in the same group. Like in the first case, that function 1, 2, 2, 3 in that.
No,
one का
I
two
am saying
image
that.
बन रहा, one का इस कारण.
Exactly. One cannot
Star
go to
and
two
one.
different places.
Two
One
images.
cannot give two output. If I remove this, then is it a function?
Yes, sir.
It is a
Yes,
function.
sir.
1 is going to 2, 2 is going to 3,
Yes,
3 is going to 1, 4 is going to 3, 5 is going to 5. So it is a function. Okay.
Sir,
One
but 2,
output
3 can
can,
take one.
two
So we have
element
to
can go
compare
to
with
same element.
the.
That can happen. It's
So
really
we have
easy.
to compare with the next element, or we have to go means we can compare with any other elements like 1,
No.
2.
So for relation, we don't have to compare anything. In relation, I mean in function, the first element represent the input, the second element represent the output. Okay.
Okay.
Now for a function,
sir,
for
these
single
conditions.
input, let me finish.
Okay.
For single input, we cannot have two different output. But for two different inputs, say for here 2 and 4, we can have single output. That is possible. That we can have. But for single element, so if 1, 4 is there, it is not possible. One cannot go to two different places. This is not possible. This is possible. Is it clear?
Like the x square.
Okay, so like there can be only one input, but there can be two outputs. Like
no, that cannot happen. For one input, cannot have two output. For a single input, if I give you 1 as my input, I cannot have 2 and 4 as my output. There should be only one output for one input. But for two different input, I can have same output. That is possible.
Suppose sir, function is in square root. Then output
I will come to example. I will come to example. But first, is this clear? And what is the relation between function and relation? Is
yes, sir. Clear, sir.
Oh, yes, sir, it's clear.
Yes, sir. Clear.
So what I can conclude from here, all functions are relations, right? All functions are relation, but all relations are not functions.
So can we say that relation is a subset of function?
Function is a subset of relation. And it not necessarily always a subset. I mean, it depends. I mean, there is a relation. I mean, this is the statement what I am talking. There is not basically a subset kind of thing. So if you take any function, that is a relation. But if you take a relation, that may not be a function. That only we can say. Okay? Is it clear?
So for a relation to be a function, it should satisfy these two conditions which you mentioned.
These two conditions, yeah, exactly. Every element should be taken to somewhere. I mean, every element should be taken as an input. And the second one is one input cannot give two different output. So let me check whether you have understood this or not. Okay, I will give example. Okay, so suppose I am working only with one set. 2, 3. Okay, let's work with two set to begin with. And say 3, 4, 6. Two set. You may become 2, 7. Okay. Now I am defining a relation 1, 3, 2, 4, 3, 4. Is R a function?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Why?
As every
Because
input
there
is,
is a
related
there
to
is distinct input.
Distinct input, correct. So distinct input means if I take 1, I am going somewhere. If I take 2, I am going somewhere. I take 3, I am going somewhere. And no element is going to two different places, right? 1 is going to 3, 2 is going to 4, and 3 is also going to 4. This can happen, but no element is going to two different output. That is clear. And I have considered all element of A. That is also one condition, right? All elements should be taken as input. That I am doing. So this is yes. Now tell me this one. Is this a function?
No, sir.
Why?
Yes, sir.
yes,
Sure.
yes, sir.
Yes,
Yes.
Yes, sir.
Yes, sir. It is a
Yes, sir.
function.
No, it is not a function.
it's not a function.
Not
Not
a
a
function.
function.
Many outputs.
It has
Same
same
output,
output
sir.
for two
Same
different
output, sir.
inputs.
No, output does not matter.
3
Here,
have
There is one input.
one is going to 3,
one
that is
element
okay.
3 in A is missing.
Right. 3 is
Supposed
not
to be
going to
related to
somewhere,
something.
right? I have not taken 3 in account. 3 is inside A, but 3 is not going to somewhere. I have not taken 3 as an input, right? So it is not a function. Is it clear?
I didn't get it, sir. Please can you?
Here 1 is going to 3, 2 is going to 3, but 3 is there, no? For A, 3 is there. but I have not taken 3 as an input.
That means
that
we
was
have
the
to.
first condition, right?
That means we have to collect all these inputs.
Exactly.
Thank you.
Clear?
Yes,
Thank
sir.
you, sir.
Clear?
Yeah.
Okay, so 3, I don't know where it goes because I have not taken 3 into the account. So it is not a function. Again, say R is 1, 3, 1, 4, 2, 3, 3, 4. Is that a function?
No, sir.
No,
Right?
sir.
Oh, sir.
V1
One is
No,
going to
sir.
3 and 4.
Repetition
Because
Because
input is
one is
there.
going to 2 outputs.
Yes, sir.
Because one is going to
One is giving
two
two
different places.
different outputs.
One
Two
is going to
output. Not
3
the
and 4,
function.
and 2 is going to.
Correct. 2 is going to 3 and 3 is going to 4. So 1 is going to 2 different places. This
Yeah,
is
so
not
that should
possible.
not.
Clear?
Yes, sir.
Yes, sir.
Okay. So the relation, the relation between relation and function, is it clear?
Yes, sir.
Yes, sir.
Sir, can you elaborate some domain and ranges?
I am coming to that. Yeah. So at least this part is clear, right? Relation and function. How they are related. This part is clear,
Yes, sir, it's
right?
clear.
Yes,
I have
sir.
one
Okay.
question.
Yeah, go ahead.
If there is only one element, like 2 comma 2, is it transitive or not? It has to be A comma B comma C, or it can work with 2
So
comma
a
2.
relation only with 2 comma 2, right?
Correct.
You tell me, is it transitive?
No, it is not. That's what I'm just.
What?
It is
Yes, sir. It is
It is transitive because
transitive.
there is no such pair, no A comma B and B comma C. If such pair exists, then we have to check for A comma C. But to begin with, I don't have any such pair.
Okay.
Right?
Yes, sir.
So it is obviously transitive.
Sir,
Yeah?
please also tell that how to solve these questions also.
Which questions?
Yes.
Which question? Hello?
Sir, assignment question.
I will come to that, but I think many of you are having problem with the concept itself. I think it should be clear.
Yes, sir. Yes, sir. First the concept.
Yes, sir.
First the concept, sir.
Yes.
Let me discuss this. Then there are many live sessions throughout the week. We can solve problem there, right?
Yes, sir.
First
Many
clarify your
doubts
concept.
for chapter. Yes.
Yeah. So this part is clear, right?
Questions.
Yeah, Tejas. What?
Yes, sir.
Tejas? Tejas? Tejas, are you saying something?
No, sir. Just
Hello, sir. I have to say something. Like we see in relation, we see transitivity, symmetric, and reflexivity. Do we see the same in case of function also? Like we have to check for function is transitive or not?
No. That is only for relation because function there is everything is fixed. I mean, we cannot interchange.
Okay,
right?
so like a function is a special type of relation. We can
A special type of relation, but for when we come to function, we don't have to bother about reflexivity, symmetricity, and all those because function we need some other definitions, right? That I am coming now.
Okay, sure.
Okay. Okay, fine. Now, so function you have understood how it is related to relation that you have understood. Now I have two things, A and B. I have function. So it is taking input from here and giving output here, right? From where it is taking its input, that is called domain of a function. And the where we are expecting the output, that is called codomain of a function. Okay. Let me give you an example. And the set of output is basically range of a function. So there are three things: codomain, and range. So suppose I am giving you the first example, if R to R, fx equal to x square. What does this notation mean? So first of all, what is domain of the function? What is domain of A? Domain of N means from where we can take input. From which set we can take the input.
from set A.
So here, what is that set?
R.
All real numbers.
All real
All
numbers.
real numbers.
So I can take any real number as an input. I will get some x square, right?
Yes.
If I give you any real number, you can square it and give me some output, right?
Yes.
Clear?
Sir, is domain a subset of a set?
Domain is subset of a set.
What does it mean? Domain is a set. Domain is a set from which we are taking the input.
So I think he's asking that if we choose, can we choose the all the elements selected in the domain should contain all the elements of the real number, or maybe we can select a
For
part.
different function, it will come differently. Okay. It may not be always a whole real number. It may not be like. I will give you example. Okay. So first of all, for this function, what is the domain? I can take any real number. I can get an output, right? So what is my domain here? My domain is
R.
set of all real number R. Yeah. Okay.
Yeah.
Where I am expecting the output. So whatever the value the output gives, that is the real number that I know. So this is my codomain. Codomain is also R here. Codomain will be given. Okay. Codomain is also R here. Now, what is my range? That is really important. Range of F. What is that? This is set of output. Can you tell me what is the set of output for this function?
X square.
X square is just a notation.
Infinity.
Real
They're
greater
all
than
positive.
Infinity.
All positive.
So
All
set of
positive
real
values.
numbers will be the output.
So first, exactly. First, tell me, can we get any negative number by output?
No.
No,
Can
sir.
we have some negative number?
No,
as
sir,
an
we can't
output?
have
No,
negative
sir.
number.
So when we are squaring a real number, we cannot have any negative number as an output, right?
Yes, sir.
We cannot have that. So, and every positive number you can take, that I can get as an output, right? If you can give me any positive number, suppose you are giving me 2, can I get it as an output?
4.
Is
Yes,
it?
sir.
Yes, so you can get it.
Yes.
What is the input?
Input is 2.
Root 2.
Root 2 is your input. I am giving you the output first. So your input should be root 2. Right?
Yes, sir. Yes, sir.
Yes.
Okay. So if you give me any positive real number, I can just take square root and that will be my input.
Both
So
plus root 2 and minus root 2 will be the input.
Yeah, both plus root 2 and minus root 2, right? So this is just positive real number, R plus. I am denoting it R plus. So this is basically all numbers starting from 0 to infinity, right? Whatever large it may be.
Yes, sir.
All positive real numbers, correct? So difference between codomain and range is clear. Codomain is where we are expecting the output. Whatever the output is, it should be real, first of all. So codomain is real number. But here my range is only set of positive number. So range may not be always equal to the codomain. Is it clear?
Yes, sir.
Yes, sir.
But what I can say, range is always a subset of codomain. Because that is what I have defined, right? Range is only set of output and codomain is the set where I am expecting my output. Okay, so range is always sitting inside that. So if I draw diagrammatically, this is my domain. I am taking my F. This is my codomain.
Codomain. The range is a set.
Range should be something inside that. This only the outputs. This is my range. Is this diagram clear?
Yes, sir.
Always
Yes, sir.
remember this diagram.
Yes, sir. Yeah.
Okay, always remember this diagram. Okay, fine.
Infinity will be the open notation, right?
Can you please
Hi, because infinity is not a number.
range?
Correct. Okay, thanks.
Yeah.
Minimum and maximum range of X square.
Maximum range. What does it mean? Range is a set. So I think you are saying what is the maximum output for x square? I think you are asking that.
Yes,
right?
sir. Yes, sir. Yes.
There is no maximum element, as you can see. It can be as large as possible.
Minimum
Sir,
is 0.
Minimum.
Minimum
Sir,
zero,
what
that
if
is
a
possible.
function of x is equal to x minus 1?
I am coming to that.
Yeah.
I am coming to that. I will give you many examples, okay?
Yeah.
So first of all, tell me till now, are you with me? What is domain, codomain, and range? Is
Yes,
that
sir.
part
Yes,
clear?
sir. Yes.
Okay.
Yes, sir.
I am giving you another
Yes, sir.
example first. So I am taking some function which I am defining it as 1 by x. Okay.
Yeah.
Now, can you tell me what is the domain of f?
Real
R
numbers.
R
All
minus
real
R
numbers
R
minus
except
positive,
zero.
sir.
X positive.
R positive.
R minus zero.
sir, all
Okay. Someone is
five by
saying all positive number, but what if we give input as negative number? Is it creating
No,
any
sir.
difference?
yes,
We
sir.
can give, right? We can
Sir,
give negative number as an input,
sir,
right?
all real except 0.
Except
Exactly.
zeros.
Minus
Exactly.
infinitive to infinitive zone.
Except 0, right? We cannot give
Except
0
zero,
as an
yes.
input,
Yes,
right? Because 1 by 0 is not defined, correct? So for this, domain is R minus 0. Is it clear?
yes, sir.
Okay. Can you tell me, so what is range of this
So can you
function?
please explain this briefly? The domain f is equal to r minus 0.
So can you give me 0 as an input? Can you give 0 as an input to the function?
No, sir. It will be
No, if
not.
you
No, sir. How
give
can
0
you?
as an input, the function is undefined, right?
Yeah.
Yes, sir.
Yeah, so 0
Yes,
is
So
sir.
not
1
in
by
the domain.
0
Other than that,
and
everything is in domain. Other than that, you can give anything as an input, any real number. Okay. Now, can you tell me what is range of this function?
R.
Is it clear?
Yes, sir.
Any real
Yes,
number
sir.
I can get an output.
Yes,
Okay.
sir. Clear, but sir, please some examples.
This is one example, no?
Sir,
Sir,
domain and range.
This is the one example of domain and range. I am giving you a harder
Yes, sir.
example. That's what if you are asking.
So, but can we get 0 as a answer?
Huh?
Can we get 0 as an answer for this function?
So that is what I am going to ask you next. Can you get 0 as an answer? I mean 0 as an output for this?
No,
No,
sir.
sir.
No,
No,
sir.
right?
Yeah.
Yes, sir.
No, sir.
Yes, sir.
Because we can go tending to 0, but we cannot get exactly 0.
Yes, sir.
Yes, sir.
Yes, sir.
Can we get that? We cannot get, right?
Yes, sir.
We don't know what is the output for that. I mean, what should be the input for that, right? Do
Yes.
we know that?
No, sir.
No, sir.
So basically range is also R minus 0. We cannot get 0 here, right? Clear?
Yeah,
Okay,
yeah.
sir.
Yes,
Clear.
sir.
Yes.
Okay,
Yes, sir. Clear.
great. Okay, let me come to some different things. So, okay. If x 1 by x minus 9. What is the domain of this function?
Sir,
R
Minus
minus
0
9.
and 9.
No,
All
0,
reals
Any
I
except
can
zero
give
which is
0 as an
9.
any
input.
0 minus 9.
All reals
So,
except for 9.
except for 9. Only 9 we cannot give an input. Because whenever I am giving input as 9, the denominator will become 0. That we cannot happen. We cannot go to happen, right? So domain is R minus 9. Correct?
Yes, sir.
Okay, great.
Yes, sir. Correct.
Now, yeah. So now, suppose I am giving you a root over x plus, say, minus 4. So I am coming to the complicated example. Can you tell me the domain of this function?
Sir, so what about the
Greater than
range?
0.
greater than equal to 4.
Closed
Example.
bracket 4 to infinity.
Sir, 4 to infinity.
Okay. So what was the range of the earlier example?
4 to positive
Real
infinity.
numbers.
Sir, it
First
can
of
be
all,
Real
what
0
is
number
or
except 0.
infinity.
All real.
Except 0.
so what was the range for the earlier example? Just tell
Same
me.
as the domain.
9 infinity.
Same as the domain.
Is it?
No, sir.
Sir,
All
only
real
real.
No,
number
sir.
All
We
except
real.
can't take
Can be
that.
positive
So
or
we get
negative,
two
any real.
range.
Equal to greater than 4, sir.
Huh?
Equal to greater than 4.
R minus 0.
R minus 0. Yes.
Okay. Can we get 9 as an output?
Yes.
Yes, sir. We can
Yes,
get.
So
sir.
what should be
Yes,
the
sir.
input? What should be the input?
No, sir.
No, we don't get entry.
So for getting 9 as an output, we should have like this,
85,
right?
sir.
What did it
85.
Sorry.
85.
No, sir.
85, sir. If you give x as 85, it will be 81
Actually,
and
sir
then
is
we get
asking
9.
domain of F.
85, you are saying 85?
To get 9 as an output, sir. If we
So
put
if you
x as
give 85 as an input, what
X will only come in the denominator.
9 points, sir.
Sir, in the next function, I'm talking about
Then
root x
1.
is x minus 4.
No, I am
82 by
not talking
9.
about the root. I am talking about this function. Can we get 9 as
Sir,
an output?
it is the
But
same as the
82 by
domain.
9.
All reals except 9.
9 point
9x minus
something kush.
81, right?
Then 9 point something kush.
It will be 8 by
So
9.
9x equal to 82.
82 by 9. Yeah.
9
82
point.
by 9. So this is a real number. This is, if I give this as an input, I will get 9. So 9 I can get as an input. So clearly it is not same as domain. What is the range? R minus 0, right?
R minus 0.
Again, we don't know when 0 comes, right? We cannot
I didn't
get
get
any
domain
number
and range
as
in
an
above
input.
example. I didn't understand domain and range in above examples.
Any one of these.
No, sir.
Can I know, I mean, where is your problem?
In first example, their domain is equals to R. And then
For x square, can I get any negative number as my output?
no, sir.
No. So can I get all positive number as my output?
Yes, sir.
Yes, sir.
So that's the range, no? The set of output. So output is all
Included
positive,
0, sir.
including 0.
Okay, sir.
Right? Now
Sir,
for the second one.
Sir, domain. I didn't get in domain.
For first one.
Yeah.
Okay. What input can you give to the function?
What, sir?
What inputs can you give to the function? Can it be any real number?
Any real number.
So that's my domain, R.
Okay.
Minus infinity.
Okay. Now for 1 by x.
Can you please explain another time? Means again that range of the second problem. I don't get it.
I am coming to that. For 1 by x, what are the inputs?
Any real number.
Any real number. Like.
Can you give 0 as an input?
No.
No, sir.
So any real number except 0, right?
Yes, sir.
Yes, sir.
Got it? So domain is R minus 0. Is it clear?
Yes, sir.
Yes, sir. Clear.
For range, can you get 0 as an output?
No, sir.
We don't know for what x it will become 0, right?
Yeah.
So 0 cannot be an output, correct?
Yes.
Yes, sir.
And other than 0, everything I can get as an output, right? Is it clear?
Yes, sir.
No, sir.
Other than 0, any real number.
We can get anything, right?
Same range
Go with.
There's some
1 by 1.
confusion for this.
For this one.
Yes, sir.
Suppose I want 2 as an output. Can you give me an input for which 2 will be an output for this function?
1 by 2.
1 by 2. If you give your input as 1 by 2, then your output will be 1 by 1 by 2, that is 2. So I can get 2 as an output. Now, if you give me any real number, A, what should be your input?
Yes, sir.
What should be your input? To get A as an output?
1 by A.
1 by A.
1 by A. Because if I give 1 by A as my input,
Yes,
1 by 1 by A, that is A, right? So I can get A as my output, right?
A. Yes, sir.
Yes.
So any real number I can get as an output except 0, because what happens if we want to get 0 as an output? We should give input as 1 by 0, but 1 by 0 is not defined, right?
Yes, sir.
So I cannot get 0 as an output. Is it clear? Other than 0, I can get any real number as an output. Is it clear?
Yes.
Yes, sir.
Yes,
Clear.
sir.
Yes, sir.
Clear to everyone?
Yes, sir. Clear.
Yes, sir. It's clear.
So what it
Yes, sir.
says it's a natural number. It goes. What if we
Any
say
real number I am saying, any real number, anything. Natural number is a part of real number. It's a subset of real number. So obviously it is there. Okay?
So
Yeah.
natural number it's okay. Okay, sir. Okay, got it. Okay.
Got it, no? I mean, real number is a very big thing. Natural number is just a part of that.
Okay.
Okay, great.
Real number should
Sir,
Second example.
I have doubt in that
Second
in
example,
which you
please, sir,
mentioned
please.
that x is equal to 82, we get 9.
I am coming to that. For this example, what is the domain? First tell me what is the domain.
Which one, sir? Under root x minus
This
4?
one. This one.
Sir, sir.
4.
Any real number.
Sir, which one domain?
1 by x minus 9.
Any real number which is not equal to 9.
Let me mute again all. I am getting again many noises there. Okay. 1 by x minus 9. What is the domain for that?
Domain is all the numbers, all the real numbers, which is not 9. Except
Is
9.
it clear to everyone?
Yes, sir.
Yes, sir.
Yes,
I
sir.
can give any input, only I have to take care when the denominator is not 0. Right?
Yes, sir.
That is one thing. So any real number except 9. Okay?
Except 9, yes, sir.
Okay.
Yes.
What about the state of output? What about the range? Range is set of output, right? What type of output I can get? First of all, can I get 0 as an output?
No, sir.
No, sir.
Why? Why?
So because
Because
if
9 is
1 by
not
9
defined.
equal to 0,
Or 0
it will just vanish
not
out from the
defined.
system.
So if I want to get 0 as an output, what should I get? I should find some x for which this equation hold, right?
Yeah.
Yes, sir.
But what does it mean?
Yes,
It means
sir.
1 equal to 0, which is absurd, right? So
Yes,
there
sir.
cannot be any x for
89.
which this is equal to 0. So 0 cannot be an output. Is it clear?
Yes, sir, clear.
Yes, sir.
Clear. And what about other real number? Can I find any other real number as an output?
Yes, so we can check like that.
Yes,
You
sir.
can just take any number and check it like that also.
You can take any number. Suppose I want to find a as an output. What input should I give? My input should be the solution for x, right? In this equation.
Yes, sir, right. Yes, sir.
This is what I need, right?
Yes, sir.
I need to find some x. So what I will do? Ax minus 9a, 1 plus 9a equal to ax. So x should be 1 plus 9a by a. So if I give this input 1 plus 9a by a, if I give x equal to 1 plus 9a by a, then I will get a as an output, right? Any real number. A can be any real number. So any real number will be my output. Clear?
Yes, sir.
Yes, sir, clear.
So the range is all real number except 0. Is it clear?
Yes, sir.
Yes, sir.
Any doubt till this portion?
No, sir.
No, sir.
No,
Sir,
So we can take a number by ourselves, like any particular number except then 0.
I mean, that's what we are checking. No, we are checking whether I can get any real number as my output or not. If we cannot get all real number as my output, then I will change my range. That is the point. We are finding the range. Correct? For this function, I can definitely get every real number as my output except 0. Is it clear?
Sir, only real
Any
number
doubt?
is output?
What type of number are you interested in?
So real number?
I mean, what is the question? I am not getting. What is the question?
Only real number is output, or another number is?
Another number means what? Can you tell me any other type of number?
Sir,
Except 0
Just
real
tell
numbers
me.
output.
Just tell me what other type of number you know. Just tell me.
means the natural number, yeah.
Natural number is a real number, right?
Yes, sir.
So if I have checked for all real number, then I have completed all the number. Natural number, integer, rational, irrational, all we have checked, right?
Only except 0.
Only except 0, exactly.
Okay.
Is it clear?
Yes, sir, clear.
So hopefully this you know. This is your natural number. This is your integer. Then you have rational number.
Rational number.
Q.
Real number.
Then real number will contain everything.
Yes, sir.
Right? So if I am talking about real number, then these are already in between that. Right? And in this program, we are only concerned about real number. We are not going to imaginary number, which is complex number and all those things. We are not doing that. Okay? Clear?
Sir, in our
Yes,
example, 1 divided by x minus 9, if we put 0, then how will it turns out to be 0, and how the range will be 0?
No, when I have said that if I put 0, it will give me 0. I have not said that.
Then how can range be except 0?
Except 0 means what? Range means set of output. Can I get 0 as my output? Can I get 0 as my output? That is my question.
I didn't get it, sir. What are you asking me?
Okay. So
I'm
if
also
I...
sir.
Okay, I will explain that. So if I want to get 0 as my output, what should I have? I should have some x for which this happened, right? I should find some x for which this happened, right?
Yeah.
Then I can say 0 I will get as an output, right?
Yes.
Can this happen?
Yes, sir.
It can happen for which x?
9 minus 9.
Is it?
So
Yes.
1 by 9 minus 9, is it 0?
It will be undefined.
Yes,
1
so it is undefined.
1 by 0, is
Because
it
it is
0?
0.
undefined.
It is undefined. So 9 is not a solution for this, right?
Okay.
Yes, sir.
Is there any other solution for this equation?
No, sir.
No, sir.
No. How can you confirm that? If I take x minus 9 this side, so I will get 0 into something that is 0. 1 equal to 0. This is absurd, right? This cannot happen anywhere. Right? 1 cannot be equal to 0. That we only know. Right?
Okay,
So
sir.
0 I cannot get as an output. Clear?
Okay. Yes, sir. Yes, sir.
But other than 0, I can get everything as an output. That I have proved. If you give this as an input, you can get A as an output. You take any real number in terms of A, I will give you this input so that I will get A as an output. Is it clear?
So negative value is the output or not?
You tell me, no. Suppose I want minus 1 as my output. What should be the number I should give here?
8.
Huh?
Okay, sir.
No, not okay. I mean, what should be the input for minus 1?
So minus input or output?
Minus 1 as my output.
Output.
What should be the input for that?
8.
8.
Minus
If I get 8 as my input, I should get
Yes,
this is
sir.
1 by minus 1, that is minus 1, right? So 8 will be my input. Is it clear?
Is it okay, sir? Is clear.
I can get any real number as my output. That is my point. If you just calculate this thing, this is what? 1 by A plus 9.
Okay, sir.
If you
Now
give this
clear.
as your input, then you will get A as an output. So this is true for any real number except 0, because 1 by 0 is undefined. So 0 we cannot get as an output. Yeah?
Okay, sir.
Clear?
Now it's clear. Clear, sir.
Okay. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir. Clear.
Yes, sir.
Okay, fine. Then this example, what I was doing, x minus 4. Okay?
Sir,
What is domain? First tell me
Greater
what
than
is
equal
domain.
to 4. Greater than equal to 0.
X is greater than equal to 4, sir.
Why?
Sir, I
Why?
think it will be from 4
Because
to infinity.
under root may
Why?
not be negative number.
Why?
Your number square root is complex number.
Less than 4, it will be minus root
Exactly. So under root, we cannot have any negative number, right?
Yes,
sir.
Because if we want my output in real number, because we are only interested in real valued function. So real valued function means codomain is real number. So we are expecting the output inside real number, right? Now, if I take this thing, this is not a real number. This is some imaginary number, right? So we don't want this as an output, correct?
I have a question here.
Yeah.
If we find root over of anything, supposing we are finding root over of plus 4, then we get two values, plus 2 and minus 2.
No, root over of something, this is a number. When you are talking about solution of this thing, then we get two things, plus and minus 2. But this is a particular number.
Okay, sir.
So you know root 2, right? And minus root 2. These are two different things.
Okay.
This is a notation altogether. This is a positive thing.
Okay.
Yeah. So root over 4 and minus root over 4 are two different things. First one is 2, second one is minus 2. Clear?
Yes, sir.
Yes.
Okay.
So can we treat this? Can we treat any such root over of something as function?
Yeah, that's what I am doing.
Okay, sir.
Okay. Yeah. So inside root there cannot be negative number, right?
Yes, sir.
So whatever the thing which is inside the root, that should be greater than 0, greater than equal to 0, right? So x should be greater than equal to 4. If we take
Yes,
any
sir.
number, any real number which is less than 4.
Not greater than or equal to. It's greater than 4 should be.
No,
Why?
it's
If
greater
Oh,
than
it's greater than or equal to.
Defined,
It's
right?
greater than equal to.
Square root of 0 is
Greater than
defined,
equal
that is
to.
0. Right?
it's 0, sir.
Square root
Yeah,
of 0
root
is
0
0.
is equal to
That is
0.
defined.
Yes.
Yes.
Correct? So greater than equal. Okay?
Yeah, okay, sir.
So domain is all such real numbers such that x is greater than 4. Clear?
Yes, sir.
Okay. And what are the other way we can write it? We can write it as this.
4 to infinite.
Okay,
Yes,
this
sir.
is closed because we are including 4.
Yes, sir.
This is
Yes,
square
sir.
bracket.
Yes, sir.
It's called closed. Okay? Okay, fine.
Continue.
Any doubt in this point? Domain of this function
No, sir.
is 4 to
No,
infinity?
sir. No, sir.
No, sir.
Everyone?
Sir, why infinity is open, sir?
I mean, there is
Because
infinity is not a
infinity is
number.
not
I mean, this means
not a number.
all the real number which is greater than 4.
number.
Okay?
Yes.
Clear?
Yes.
Yes,
Sir,
sir.
clear.
Okay. Now, what is range of this function?
From 0 to
Positive real number?
infinity.
Yeah. Why?
Positive real number.
Why?
Yeah.
Because
This
root
is what just now I have said. This
Sir.
notation is basically denotes some positive number. Root a means some positive number greater than 0, right?
Okay.
0 or greater than 0. So we can get the output as all such
0.
real number which is greater than equal to 0.
Yes.
This is 0
Output
to infinity.
sir, negative number and positive number also.
Negative we cannot get because square root function, this is only positive thing. Okay, just now I have said root 2 means it is on the positive side, right? There are two
But
things,
sir,
root 2 and minus root 2.
root
Minus
4
root 2 is
जी but sir root 4 का value sir -2 and 2 also.
no, that is what I am saying. Please listen what I am saying first. When I am talking about this root 4, this is what? This is just 2. This is not minus 2. Because if you draw the number line, where is root 2? Here, right? There is another number which is minus root 2, right?
1.414.
So here is your root 4. Here is minus root 4. Okay? So got it? No, root 4 is just 2. This is the notation we are taking.
Yes, sir.
Square root of something
Sir,
is
in
a positive
activity
number.
question number. Sir, in activity 9, question number 5, we deal with minus root something value, sir.
That can be. No, minus root x minus 3. Then it is a negative number. Then
No,
it is always
sir,
a negative number.
no, sir, root of 10 minus x. It can be, sir, like we get something like if it is greater than 10, we get some root of minus value.
No, you are not getting. You are again misinterpreting something. So let me open it and then we can discuss. Okay? I am opening.
I think it was asked whether the function is injective or not.
Yeah, that I know.
Yes,
I mean, he is misinterpreting something. So that I know.
Yeah.
So for now, just consider it whenever I am talking about root thing, because it will be get delayed otherwise. Whenever I am consider about this thing, this is a positive number, right? If there is minus thing, this is negative number. Okay? Clear?
Okay, sir.
Yes, sir.
So range of this function is starting from 0 going to infinity. Okay? All the output will be a positive real number. Clear?
Yes.
Clear.
Yes, sir. Clear, sir.
Okay. So this range and domain is clear to everyone?
Yes, sir.
Yes, sir. Yes,
One
sir.
small doubt.
Yes, sir.
Yeah.
Yes, sir. One small doubt. Suppose, like you just put that something within square root, right? So let's say if it is, oh, I'm just missing it. Just a second. Can you just write down what you asked?
Where? Which one? Just tell me which one should I
You
write?
just it. You just rubbed it off.
Okay, this number line, is it?
Not
it
that.
This one? Okay.
Something within the root, within the square root. You were explaining about that four thing. I mean, square root.
Okay, root 4.
Yeah. So this has something like plus or minus 2 as the.
No. That is what I am saying. This is a symbol which represents a positive number, which is 2. Root 2. Okay. If I give you root 2, is it positive or negative?
This is positive.
Then why root 4 is negative?
No, root 4 is not negative, but the solution. Okay.
Negative.
Do you get my point? This is a number. This is a notation altogether. Root A is a number.
Okay.
This is a notation. Okay.
Amen.
We are not
I get it.
giving the solution of this. This has two solutions, x2 and minus 2.
Okay, sir, I get the point.
Okay. If I want the solution of this, I can write x as plus root 4 and minus root 4. These two are solution.
Okay.
One is positive, one is negative. So if I ask you what is the solution of this, what you will give me?
Plus or minus.
Will write plus minus root 2, right?
Okay, so we get that only when we solve a quadratic.
Similarly, if you give me the solution of this, what you will give me? Plus
minus
4.
Right? Plus or minus 2. So, okay, got it.
So, this is plus 4, this is 2, and minus root 4, this is minus 2. Got it?
Yeah.
So, this is a positive number. This notation denotes a positive number.
No, just a second. The last one, minus root 4, is equal to minus 2. Right. Okay. Okay. I mean, this is something which I haven't realized. Okay.
So, this is what the number looks like. Okay.
All right. Thank you.
So, square root of something is a number, which is a positive number. If I want negative of it, I should put a minus in front of that. Because this will clarify your doubt probably. This part. X square equal to 2. What does it mean? What are the solutions? Plus root 2 and minus root 2, right? So
this is the first time actually it is being defined like this. So this is also a general notation that we should consider when we solve all the problems.
And this is the only right notation. So
okay, because you know, so all the time that we have learned natural numbers to start from 1, but when the first session when we read, we learned that natural numbers should be
yes, sir. That's a doubt, sir.
No,
that has a
like
reason.
that here.
No, this is not like that. This is not like that. This is true for maths. Always true.
All right. Okay.
This is not like that. Okay.
Sir, some example of 1, 1 and 1, 2, sir.
Coming. Before going 1, 1 and 2, just give me, if you have understood this thing, what is the domain of this?
So from the
what is the domain of F?
2 to infinite.
Tell me, what is the domain of this thing?
For all real numbers
greater than 2.
Less than 2.
Except 2.
Sorry, except 2. Yes, sir.
I have got many.
Yes, sir. Except 2. Yes.
3 to infinite.
Except 2, sir.
Only except 2.
Plus or minus 2.
Okay, first of all,
than 2,
inside, okay, how you will approach this type of problem? You have a square root, right? So inside the square root, whatever it is, it should be greater than 0. That is the first thing, greater than equal to 0, right? Yes. This is the first thing you should consider. What does it mean? X minus 2 should be?
Greater than 0.
Less than.
Less than or greater than?
Less than.
Greater than.
Greater than, sir.
All x greater than or equal to 3.
Greater than.
All x greater than or equal to 3.
Greater than equal to?
3.
0.
3. Why?
Sorry, 2.
Greater than or equal to 2.
Now, okay, fine. This is what we are getting. To make it positive number, we should put all the real number greater than equal to 2. Now, can we put 2 here? Because it is also in the denominator, right? So, denominator cannot be equal to 0.
Yes, so we
the
can't.
Denominator cannot be 0.
Minus infinity to infinity. All real numbers Less than 0.
Should be greater than 2.
What are you saying?
Sir, it should be greater than 3, greater than 2, right? Because if we put
Yeah, I am
3,
coming to
we
that. That's
are
why I am
getting like
taking.
positive numbers. Oh, okay.
That's what I am writing. So x cannot be 2, right? Because if we put 2, it will be 1 by 0. So it cannot happen. And here I am getting x should be greater than equal to 2. So what eventually the domain is all real number which is strictly greater than 2. Correct?
Which is strictly greater than 2.
Correct. So it is basically open to infinity.
2 to infinite.
I am putting open because I cannot include. So this open bracket.
Sir, why x minus 2 is greater than or equal to 0?
Because it is under square root, it cannot be negative. Right? If you put 1, what will happen? 1 minus 1 by 1 minus 2, so it is minus 1. So square root of minus 1. It is not a real number. No?
So both denominator and numerator should be positive. Since it is under
I mean here numerator is 1. So it is always positive. So we need denominator should be positive. That's what I have written, right?
Okay.
Clear? And it cannot be equal to 2 because then the denominator will go to 0. That is not possible. So I eliminate that also. So it is 2 to infinity. Is it clear?
Yes, sir.
Yes, sir.
Okay. And what is the range of this function?
Of what you did 1 by x minus 2 greater than or equal to 0. I didn't get that solution. Now you did.
You got it, is it?
Sir, 1 to infinity, the range.
No, sir. Positive real numbers.
Any positive real number?
Positive.
Yeah.
No.
Hello, sir. Why cannot I get any real number?
Sir, can we get a 0 for the solution?
Get 0.
I mean, for this
so I am
function,
asking, is it the range? Is it this?
No.
Is it the range?
No.
What?
You can't get 0 for the solution, sir. If
Exactly.
if,
We cannot
sir,
get
if
0 for
we-
the solution.
No.
Again, if I put this,
like
then again I am getting 1 equal to 0, which is absurd, right? So I cannot have any input for which I am getting 0 in my solution. So 0 is not there. So I am eliminating 0. Can I get everything other than 0? All positive real number? Can I get that?
Yes.
Yes, sir, we can get that.
Yes, sir.
How?
No, sir, we will
So
get
we can
everything
get
less
that.
than 1.
Why?
Because the denominator will always be greater than
It should
1.
not be minus.
Are greater than
minus we cannot get, that is clear because it is under square root. So it is always positive. And 0 we cannot get. But can we get any positive real number? That is the question.
Yes, sir. We can get.
Yes.
Why? So suppose I want any positive real number, A, as a solution. What should be my input? So I should find some x, right? For which this satisfied, right?
Yeah.
That's how you do that. So if we put square on both sides, what I will get? A square. Then x minus 2 is basically 1 by a square. Then your x is 1 by a square plus 2. So this is your input. If you give this as an input, you will get A as a solution. Right? Any positive real number you can get as a solution.
Yes.
I have doubt.
Yeah, go ahead.
Sir, when we solve inequality equation, we change the sign of inequality when we multiply and divide.
But
So
here
why
we are doing with 0. Remember that. We cannot just, we cannot multiply it with here. Otherwise, I will get 1 greater than equal to 0. So what we are doing here, if a fraction is greater than equal to 0, then both numerator and denominator should be greater than equal to 0, right? Or both should be negative. But here, the above is positive. So the denominator is also should positive, right?
Yes.
Got it, no?
So, but why did we take equal to 0? Denominator cannot be equal to 0.
That I coming later, no? I have not taken. Eventually, I have eliminated minus 2. I have taken account of this. Got it, no?
Okay, got it. Yeah, I got it.
Okay. So domain of the function is 2 to infinity, where 2 is open. Range is 0 to infinity, where 0 is open. Is it clear to everyone?
Yes, sir.
Range will be 0, 1, right? With closed interval?
Why 1? It can be greater than 1 also, right? I have just now shown you. Take any real number. I can get a solution. I can give you an input so that I can get A as a solution.
I mean, if 1 by whatever it starts from the 0 only, right? sorry, one like 0 point something, right? And it, let's say, goes to 100, let's say 1 per 100, right? So it output will be 1 by 10 only, right?
So I mean, I am not understanding what your doubt is. Can you give me a little bit clarification on that?
Sir,
Can you
I think
repeat what
he's
your
trying to
doubt
say,
is?
like, sir, I think he's trying to say, if any input that we are giving to X, it's like a fraction. So it's 1 by something, like whatever we put
No,
in
why it is
there.
fraction? It can be anything. It is starting
He's
from.
trying to say that, actually.
No, that is not true. I can give you any, I mean, input is from where? 2 to infinity, right? Any number. Any real number between 2 and infinity, right? And my question is, I mean, can I get every number as my output? Every positive number? The answer is yes, I can get.
Yes. Yes.
So can you please explain how we get 0 in the range?
No, I am not getting 0 in the range. That's why I have put it open.
Open. All
I
right.
am not
Okay.
getting
Sorry.
zero
Yeah,
in
yeah.
the range.
Yeah. Got it.
Right?
Got it.
So I am getting only positive real number as my output. Is this clear to everyone?
I'm sorry, I got disconnected actually. I think I was talking about this 1 by 100, let's say, for example, and output will be 1 by 10, right? For that, and that
whatever that is, I am not sure. Whatever that is, but what is your? I mean,
point is that the range will be, it's a 0,1 with a closed interval. That was my
why
point.
you cannot get 2 as an output? You are saying?
Yeah, that's the point. Yeah.
Okay, so let me find what should be the output for 2. Right? Let's see if I can find it or not. So what it should be? X minus 2 should be 4. Then x minus 2 is 1 by 4. Then x is 2 plus 1 by 4. If I give 2 plus 1 by 4 as my input, I am claiming that my output is 2. Right? You substitute 2 plus 1 by 4 here. 1 by 2 plus 1 by 4 minus 2. Square root of this. 2 to cancel out. So this is square root of 4. This is 2. Is it clear?
Yeah, got it.
So any real number I can get as, see, this is my input. You give me this input, I will get A as my output. Where A is any positive real number. Is it clear?
Yeah, thanks for the explanation.
Clear, sir. Okay, fine. Okay, so this is the domain and range part. Now come to the last question.
Sir, will you please do 1.9 fifth question?
No, I will not do now. I will finish this part, then I will go to that, okay?
Yes, sir. Yes, sir.
Okay, sir.
Okay. So 1-to-1 and on-to function. This is called injective.
Yes.
Surjective.
Surjective.
Okay, now when I call 1-1 function, a function 1-1, this is my domain, right?
Yes.
Yes, sir.
This is my codomain. I have function f. If two input
Domain equal to range.
What are you saying? If two input, I have two input for which I have same output, then it is not 1-1. Okay? If this happens, then this is not 1-1. Is it clear? Example, fx equal to x square. If I give you -2, what is my output? 4. Or +2, what is my output? 4. So there are two numbers for which I am getting same output. So 2 input is giving me same output. So it is not 1-to-1. Okay, clear?
Yes, sir. So it is many one.
Sir, it is given many to one.
But we really don't need that name. Okay, it is either 1-to-1 or not 1-to-1. That's only enough.
Okay, sir.
Okay, so
Yes,
it's not injective.
Sir, it is opposite like function definition, no, sir?
Kind of, but we cannot say, but it is still a function, right? So it is strong. I mean, a stronger function, you can say, right?
Okay.
A stronger function, you can say, if you want. I mean, there is no such term, but I am saying just to remember. So this is clear?
Yes, sir, clear.
Okay. Now suppose I am giving you this function. Is it one-to-one?
Is it one to one?
Yes, sir. Sir, my internet got disconnected. Can you please explain it again?
Yes, sir.
Yeah. I am
One.
explaining it. So I am saying that two input cannot go to single output, right? That is the definition of one-to-one function. If two input is going to single output, then it is not one-to-one. That's like x square.
Excuse me?
X square, I have minus and plus of number, which are going to the same number, right?
Yes, sir.
Excuse me.
Yeah.
See, I have another class in same mathematics. Will this be available as a recording?
Yeah, it will be. There will be a YouTube recording for this.
All right.
Okay.
Because then I will leave because we have been allocated. Yeah. All right. Thank you.
Sure. Yeah. Now for what happens for this thing? So we have to check whether two input can go to same output or not. What does it mean? Suppose I have two things, A and B. These two are my inputs. So can it go to the same thing? This is my question.
No, sir, different.
So we have to prove it. So what is the output for A? 2A plus 3. What is the output for B?
2B plus 3.
3. Right? 3 got cancelled out. 2 cancel out. So 2A equal to 2B.
A is not equal to B.
So A equal to B.
Yes.
So whenever the output is same, the input is also same. What does it mean? If the input are different, they cannot go to same output.
Yes, sir.
Clear? So this is an injective function.
Yes.
Clear how you check for injectivity?
Yes, sir.
Please repeat, sir.
Yes, sir.
So for injectivity, what is we are looking for? Two input cannot go to two distinct input cannot go to same output. Okay. So I have started with two input A and B. I am checking whether they can go to same output or not. So let us assume that they are going to same output. So I am saying for A I am getting output FA and for B I am getting output FB. If they are same, what happened? Let's check that. So for input A, what is the output for this function? 2A plus 3. For B, what is the output? 2B plus 3. If the output are same, then what I am getting? 3 got cancelled out, then 2 got cancelled out, then A equal to B. So I am seeing that if two output are same, then two input must be same. So there cannot be two distinct input for which output is same. So this function is injective function. Is it clear?
Yes, sir.
Yes.
Clear to everyone?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir. Clear.
Okay. So remember this diagram. If such a situation occurs, it is not an injective function. Not injective. Okay?
Yes, sir.
Now come to surjective function.
So can you explain activity 9 injection, fifth problem?
I will come to that. But let me finish this because this is the last thing I am going to discuss. Okay?
Okay, sir.
So on to function. What is on to function? So you have again your domain. You have your codomain. Right? You have function like this. Now, the set of output is your range. Correct? This is your set of output, which is inside the codomain. This is the range.
Is equal to domain.
If so, range is always a subset of codomain, right? That we have checked. I mean, that's how it is defined. If range and codomain are same, the same set, then we call it, then F is surjective. Okay?
Yes,
if range and codomain are same, then it is surjective. What does it mean? Range means set of output, right? So I have a domain. I have a codomain. I choose any element from the codomain, any element. If I am getting an input for that, I mean there is some input for which I am getting that element as an output. What does it mean? So mean this element is inside the range, right? If it happens for all the elements in the codomain, then we call the function a surjective function. Is it clear?
Yes.
First diagram is not surjective, no sir.
Huh?
First diagram, top diagram is not surjective, no sir.
I am coming to that. So if R to R, this is your function, fx equal to x square. What is your range?
Positive numbers.
Right?
To
Only
real.
positive number, right?
Always positive.
What is your codomain?
So
R.
all
Is
real
R.
numbers.
Are these
R
two
real
equal?
number.
Not on
Is
to.
these two set equal?
No.
No.
No, sir.
Right? So this is a picture like this. This is R, and your range is something in between that, right? This is the R plus. So this R plus is not the whole codomain. So codomain is not equal to range, right? So this F is not surjective. Clear?
Yes.
Clear, no?
Yes sir. Yes sir.
What about this function? Is this surjective?
Yes.
Yes, sir.
Why?
Every value we will find some input.
What is the range of this function? First tell me. Can I get any real number as a solution?
Yes sir.
Yes, sir.
Yes, sir, we can get
Suppose
it.
I want a real number A, any real number I have chosen, A, any real number. What should be the output for that? What should be the input for that? If I want to get A as an output?
2A plus 3.
No. I want A as an output. What should be my input? My input should be...
Sir, A minus 3 by 2.
Exactly. If I give A minus 3 by 2 as my input, then I will get A as an output, right? If I give this as my input, then what I am getting? This, right? This will cancel out.
A.
So I will get A. Now this A can be any real number, right? So any real number I can get as an output because A minus 3 by 2 is a real number. Correct? This is a real number. This is an input, valid input.
Yeah.
Right. Suppose I want 5 by 2 as my output. What is the input I should put? 5 by 2 minus 3 by 2.
Minus 3 by 2.
Whatever that is, I should give this my input. I will get 5 by 2 as my output. So range is basically whole real number. And what was the codomain? Codomain is also whole real number. This is the codomain. Right? So codomain and range are same. So this is a surjective function. Okay. Is it clear?
Yes.
Yes, sir, clear.
Okay, let me ask another question. So this is R plus is your domain to R fx equal to root x. Okay, R plus means R plus including 0. Okay, so this was your domain as we have calculated. Now is it surjective?
Yes, sir.
Is it?
No, sir.
No, sir.
No, right?
No, sir.
What is the range of this function?
Positive real numbers.
Only positive real numbers, right?
It's a
Including
subset
0.
of the codomain.
No, we can have 0. Yeah. 0.
We can have 0, right?
Yeah, sir.
But it is not whole R, right? This is the codomain. So codomain and range are different, right? Range is the subset, not the whole set. So it is not surjective. Clear? Is it clear?
Yes, sir.
Yes, sir. Yes, sir.
For everyone it is clear?
Sir, so the bottom line is,
sir.
if we get any kind of square root function, like doesn't matter what kind of like mapping we are doing, maybe natural to real or real to real. So it's never going to be a surjective function since it's
if
like
your codomain
any
is
square root
whole
function
R.
has to be greater than 0, right?
Yeah, if your codomain is, let me finish it. If your codomain is whole R, but sometime, I mean, codomain is in your hand, right? If I am defining a function like this, the same function, I will define like this. 1 plus including 0. I define, I mean intentionally, my codomain as this.
Okay.
If I define my codomain like this, fx equal to root x, then this I have defined my
it could
codomain,
be the
right?
surjective.
No.
Yeah.
Then it is surjective, right? So it depends on codomain. So codomain will be given, whatever your codomain is. If it is not given, then your codomain you should consider as real number, right? Whole real number. If it is not given, otherwise it will be given.
Yeah,
Is
sir.
it clear?
Yeah.
Sir, in continuation, sir, in continuation with this question only, the answer, it is not surjective all because codomain is because our codomain also in those perfect square are not in our range. So this is the reason.
No, that is not the reason. Have you joined just now?
No, sir.
Okay. So when I was discussing fx equal to root x, what was the range of that function? Can you tell me?
All real positive numbers.
Including 0, right?
Yes.
So it, I mean, does not necessarily it should be a perfect square root or not, right?
But
I mean, root 2 is also there. Root 2 I can get. I don't need x as the perfect square, right? This is also an output, right?
Yes.
If I give
now
2,
I got
what is
got
f2? This.
I got
So
it.
any real number, but here it is not surjective because codomain was whole real number, but range is only positive real number from 0, right? So negative numbers are not there as an output. So it is not surjective.
Thank you.
Clear?
Thank you. I got it. Yeah.
Okay, great. Yeah. So what we discussed, different type of relation, how relation and functions are related, domain and range, injectivity, surjectivity. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Now, bijective function is basically, it is both injective and surjective. Okay?
Okay.
Injective and surjective. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Anyone have any doubt till this point?
Sir,
Yeah.
bisective.
Yeah, tell me.
Sir, bisective line are y is equal to mx plus c.
What is that?
Means bisective
Hmm.
y is equal to mx plus c.
I mean, you are asking whether that straight line is a bijective or not, is it?
Yes, sir.
Can you tell me what is the function there? Okay, for those who are clear with the thing, I have put some form in the chat. So this is just for keeping a track with how these sessions are going. So can you just fill this form, those who are clear with the doubt? Yeah, go ahead. What you are asking?
Can you explain maximum and minimum of function?
So
I
we
will
are not
come to
able
that.
to access
It
the.
says we can only we don't have the permission to view it.
Yes.
Is it?
Yeah, it is
Yes,
saying
sir.
so.
I think it's only access for student email ID.
Oh, okay. 1 minute. Let me change it.
Is it?
Yeah.
I
Is
think
it
it's
happening for everyone?
Yes, sir.
Yes, sir.
Yes,
I will
Last.
take your doubts. Just give me 2 minutes. I will just.
Sir,
Yes,
in
sir.
last session
It's
also
saying
this
you
was.
need permission.
In last session also this was happening, and then later on it got corrected.
What should I do here? Anyone know how I can
I think it's
fix
said to
this?
be only viewed by the organizers or something. It should be in the settings.
Where it should come?
So I think the people
Sir,
do
in
not
the
have
second
student email
option,
ID cannot
can you
access
check?
the project
It is
form.
view. Second option, view.
So they
where
need to open with student
Things
ID.
in settings, I think.
Where I
The
is
official
made.
mail ID from
Okay,
the college.
this one is it? Where I should do it? There is none, right?
No.
I was using my student email ID and
Sir,
I was
this
able to open it.
change settings.
But you have, but
Switch it
everybody
out.
don't have student here.
There is
It
this
works
change
only with
settings.
student email ID.
Yeah, change what?
Just
Change
switch
settings
it out.
is visible here. Just first line in the first box. Little down below, sir.
Change
Maybe there.
That.
Yeah.
Manage no
नहीं
responses.
Can you click on responses?
In
And it's
responses.
responses, manage responses. No. In settings. Settings, second option. Yeah.
Okay.
Just down arrow.
Yes, sir.
You can see if there's something.
Okay, this one, if I remove it, I think now you can do it.
Yeah.
Can someone just check?
Yeah, I will.
Sir, can you share link now?
Oh, I should.
Yeah, now we can do it. No, now
We
we
are
can
able
do
to
it.
access the link now.
Now we are able to access.
Thanks. I am posting it again anyway. Okay, yeah. So someone was asking about y equal to mx plus c, right?
Yes, sir.
What does this mean? First of all, let me say. So this was a straight line, right? Some straight line like this. And can I mute all of you again? Yeah. So this was a straight line, right? Where this is basically your y, this is basically your x, right? Correct? Who was asking? Can you just interact with me?
Yes, sir.
Yeah.
Sir, sorry to disturb you. This form is asking student email ID, but I don't think student email ID is.
You just put your ID. I forgot that you are in qualified batch. Put your ID.
Okay, sir.
So y and x axis. So x is your input and you are getting some output as y, right? I can consider it like that.
Yes,
right?
sir.
If I give you some x, I will get some y.
Yes, sir.
So this y I can consider as fx, right? So this y I can consider as fx. So these all those points which are satisfying this equation, that is of the form x comma fx, right? Correct?
Yes, sir.
And this is called, so you asked that actually is a good question. So this thing, this set of all such point, this is called, or inside the domain you can say, this is called graph of a function.
Graph of the function.
Graph of a function.
Okay.
You will come to know in details it in when you are studying calculus in 7th week. Okay, this is called graph of a function. Now, when I am defining a function like this, mx plus c, so this will give me, the graph will be the straight line. That is the point. That's how these two are related. Is it clear? If I plot x, my input, and fx, my output, in our xy coordinate, the picture I get, that is called the graph, right? So I will get a straight line, correct? Now your question is it this function? Is this function bijective or not, right?
Yes, sir.
That was your question. Now tell me, this is a function from R to R. Is it injective?
Is it injective?
Yes, sir. For every
Let her answer it. Let her answer. Is it injective? Nishi, right?
Yes, sir.
Is it injective?
Yes, sir.
Why?
Sir, because
so what we check? We have to check two distinct input can give me same output or not, right? So let's start with two input. Can it give me same output? Can we have fa equal to fb? If a and b are different, let's check. So what is output for a? It is ma plus c. What is output for b?
mb plus c.
C will get cancelled out. ma equal to mb.
Yes, sir. So a is equal to b.
So a and b cannot be distinct if the output is same. What does it mean?
Yes, sir.
It is
injective.
Right? Because two different input cannot give same output. This cannot happen. This first diagram cannot happen. Right? So it is injective.
Yes, sir.
Correct? Now what about surjectivity?
Surjectivity.
Surjectivity means what is the range? First tell me what is the range of the function.
Yes, sir.
Can I get any real number as an output?
I get any real number as an output.
So take any real number A, any real number A. Can I get A as an output?
Yes, sir.
How? What should be my input? Let's
Input.
find it. If this is an output, I should find some x.
Mx plus c.
I should
A
find some
minus
x for
I-
which this equation is satisfied, right?
Yes,
Yeah.
sir.
Input means what? I should give some x for which fx equal to a. Now what is fx? Fx is mx plus c. So there should be some x for which this equation will be satisfied, right?
Mm.
So let's solve for x. Mx is a minus c and x is a minus c by m. Right? If I give this as my input, I will get a as my output.
Yes.
Is it clear?
Yes, sir. Clear.
If I give a
It's
minus c by m.
Isn't there an addition that says m is not equal to 0 and
That I have assumed. M and c
Yeah.
both not 0. I have assumed.
It will say input A is equal to output.
See, I am giving this as my input. See what is my output. M will cancel out. A minus c, c cancel out. This is a. I will get my output. Correct?
Oh, okay.
So I can get any real number. I have a can be anything, right? Any real number. I can give this as my input. I will get a as my output. So I can get any real number as my output, right? Is this clear, Nishi?
Yes, sir.
So what is range?
The
Range is any real
raise
number. Correct?
all real number, no, sir?
All real number, exactly. So range is all real number. What is codomain? All real number.
All real number.
So is it surjective?
Yeah.
So
Yes,
codomain was
sir.
also R. So these two are equal. So F is surjective, right?
Yes, sir.
Correct?
And it is injective and surjective. So
So it is
bisective also.
bijective. Yeah, exactly.
Bijective.
Clear? So
Clear,
any
sir.
relation,
Thank you,
any function of this form, that is actually a good question. Any function of this form, okay, it is bijective function.
Okay, sir.
Clear?
Any linear function.
Yes, sir.
Any linear function. I don't want to mention that I'm linear because what is linear, then that is a question. But yeah, you are right. Any linear function is bijective. Okay?
So may I also ask one question?
Yeah.
So what is an
No, first of
equivalence?
all, before Rusian, is it clear to everyone? This
Yes,
question?
sir.
Yes, it's
Okay.
clear.
Yes, sir.
Yes, sir.
Shreyan. Shreyan
So
or
what is an equivalence class?
What is modulus?
that actually require more time for. So equivalence class means suppose we are starting with a set. Okay. I am starting with a set, some set. 1, 2, 3.
So maximum minimum values.
I am coming to that. Maximum minimum value I will discuss. That is not very difficult to discuss. Yeah. Now if I have a relation on A cross A. Okay, relation is a subset I have said, right? Now if this relation is equivalent relation, then it will give a partition on A. I mean those elements which are related by this relation, we can take it as a class. Okay, that will form a equivalence relation. So suppose one good example will be like this. Suppose I have set of all cricketers. Okay, all cricketers. Right? This is my set. Okay. Now I am defining a relation. Suppose set of all cricketers. This is country wise I am talking. So those players who are in the same international team of some country. So I am taking A comma B such that A and B plays in the same country. Plays for the same country, let's say. For the same country, right? Tell me, is it which type of relation is it? These are reflexive?
Sir, reflexive.
Reflexive. Why?
Sir, because two elements play for the same country, so they are related to each other.
I mean, for relative mean A comma A should be there for
Yes,
reflexive.
yes,
Now,
yes.
both
yes.
are same player. I mean, how can one player can play for two different things?
It is
That case is
symmetric.
not possible. So it is reflexive. This is yes. Is it symmetric? Is it symmetric?
Yes, yes, sir.
Yes.
Yes,
If
sir,
A
it is
and
also
B,
symmetric.
huh? Yeah, it is symmetric. If A and B are two players,
Sir, I
if they
said
are in
symmetric.
yeah, right. It is symmetric. If A and B plays for same thing, then B and A are also playing for the same country, right?
Yes.
Is our transitive.
Yes.
If A and B are in same team, A and B,
Yes.
they are in same team, and
Yes,
B
sir,
and
it is
C are in same team, then A
Yes,
and
sir,
C must be
transitive.
in same team, right?
Yes, sir, it's transitive.
Yes, sir.
Transitive. So
Yes,
it is
sir.
an equivalence relation, right?
Yes.
So R is an equivalence relation.
Equivalent.
Sorry, can you please tell me how can it be reflexive? Because reflexive means it
what?
needs
A
A
comma
comma
A
A,
should
right?
be there.
Yeah.
Now A
but
is the
is
same
this
element, right? One single person.
Yes.
Now
How can
he
you have
is
the
always
same
related to
person?
himself, right? By this relation, because he is playing for some country.
Okay.
Okay.
but is this
This
relation
is
No,
by
I
default.
was sorry. My confusion was because I was thinking, how can the same person be represented twice? Sorry.
Because this is by default. That's what I am saying.
Cartesian product.
This is by
Yep,
default.
got it.
Okay.
So is
fine.
R here A cross A? Are we saying
Yeah,
that?
R is it is a subset of A cross A. Correct.
Okay.
Okay, that's how this relation is defined. Okay, got it? So this is an equivalence relation. Now, what is equivalence class? Equivalence class means equivalence class. So take any element from this set, the original set. So this is a set of all cricketers. Let's say, give me any name. Say Rohit Sharma. Okay. I want to consider the class of Rohit Sharma. What is his class? So what does it mean? It is a set of all those players. Okay, it is a set of all those player B, or say all those player cricketers, so say C, from the set A, for which C and Rohit are related.
Those who play with Rohit Sharma.
Exactly. So basically C and Rohit, these are inside R. We want all such C. Okay. This is the class of Rohit Sharma. Is it clear to everyone?
Yes, sir.
So
Yes,
class
sir,
mean I
clear.
am taking one element from
No,
the set,
sir.
original set.
Can you repeat
I
it
am
once more?
explaining that. I am considering class of some element of the original set. Original set was A, the set of all cricketers. So I am taking one player from that, one element from that. Say Rohit Sharma. I am considering the class of Rohit Sharma. What is class of Rohit Sharma? So you consider all such players who are related to Rohit Sharma by R. So the relation was defined like A and B are placed for the same country. So can you say me who are all these players? Will Kohli be one of this class? Virat
Yes, sir.
Kohli? Will
Yes,
Virat
sir.
be inside this class?
Yes.
Right?
Yes, sir.
Virat will be inside this class because Virat comma Rohit will be inside R.
Yes.
Right? Virat
Yes,
comma
sir.
Rohit. This is one pair of R, right? This is inside R. Right?
Yes, sir.
Can give me any other name? Jadeja, right? Can Jadeja be inside this set?
Yes, sir.
He is inside this set, right? So I am taking the class of Rohit Sharma and I am considering this set. So this is the equivalent class of Rohit Sharma. Now, if I say, any other player, say Babar Azam, a Pakistani player, right? Is Babar inside the class of Rohit Sharma?
No.
No, sir.
No, right? So this is not true. But if I consider the class of Babar, what I will get eventually? Which player I
Forms
will
a
get?
separate class.
Pakistani players.
This is basically Team Pakistan, right? And if I
The set of
consider
all
class of
players
Rohit
who play
Sharma,
with Babar.
exactly, this is Team India, right? Correct?
Yes.
So
Yes,
what
sir.
it does, so it takes all the set of cricketers. This was set of cricketers. I have defined one equivalence relation. All those players who are in the same team, who are playing for the same country. So it will divide it in classes. So this will give a partition like this, where this is Team India, like that, right? This is Team Pakistan. So all the different team
I
will
see.
be
That was very
different
intuitive.
classes. So these are classes. This is class 1. This is class 2. These are same classes. So that's how a equivalence class gives a partition in a set. Okay? You understand what equivalence class is, you understand how it gives a partition, right?
Yes.
So if
Yes,
you
sir.
remember this example, I think this will be very clear to you. Any doubt in this?
Maxima, minima, sir.
Maximum, minimum. Have you, is this clear to you?
Yes, sir. Yes, sir.
Yes,
Absolutely.
sir.
Thank you very much, sir.
Maximum,
Yes,
minima
sir.
is nothing
But I have a doubt.
for
How will it
How do you find it?
what I
I
have
have
found.
doubt in equivalence relations. There's little doubt.
So the relation I have defined is like this. If
Sir,
two players are in
how
same
will it be
country,
mentioned in the question, sir?
like this is one relation I have given. This is one relation, right? This is one relation I have given. Now, in question, it can be asked that whether it is a equivalence relation or not, or it can be asked what is the class of Rohit Sharma. Then 4 options are there: Team India, Team Pakistan, Team West Indies, Team Australia.
Okay,
What is
sir.
the
I got
class?
it. I
It is
got it.
Team Australia, no? Sorry, Team India, right? Clear, no?
Yes,
Is it
sir.
clear to everyone?
Yes, sir.
Yes, sir. Clear.
Yes.
Yes,
Yes,
sir.
sir, clear.
Okay.
A maxima, minimum, sir.
Maximum minima. What is your doubt in maximum minima? Can you tell me?
Minimum of a
So for this first week,
Local maxima, local minima did not get
no, that is
understand.
not there. That is in calculus portion, first of all.
Sir, only
Here,
maxima,
what we
minimum.
need, here, yeah, I am discussing that.
Local maxima, local minima not needed, sir.
For now, it is not
Yes,
needed.
yes.
Okay, it will come in week 7. For now, it is not needed. Someone's kid is, doing
Yeah, okay, sir.
something.
Yeah, okay, sir.
Yeah. So maximum. So here only we need what is the maximum value of a function, what is the minimum value of a function can be. Right. Here we are talking about global thing. What is the maximum value of a? Suppose I am taking fx equal to x square plus 4. Okay, f is r to r. Can you tell me what is the minimum value of this function?
So,
Huh?
4.
Yeah. So it is 4 because any number which is less than 4 we cannot get an output. Right. It will start at from 4. So what will be the range of this function?
Greater
Range
than
of f 4
4.
to infinity, right?
Yes, sir.
All real number which is greater than 4. So what is the minimum value of this function?
4.
Consider range or codomain, sir, for maximum minima.
Range, no, you need output, right? You need output. What is the minimum output? What is the maximum output? That is your question, right? So you need to consider range because range is dealing with the output, right? Range is the output. So what is the minimum number in the set? That is what we are asking.
4 is minimum.
Clear?
Yes.
Clear, no?
Yes.
Yes, sir. Yes, sir. Carry on.
Okay. Yes. So suppose I am giving you another example. Fx is say x square minus 9. What is the minimum value of this function?
Minus 9.
It's 9.
Minus 9. It is clear?
Yes.
Yeah. Okay. Now suppose let it complicate it little bit more. This is minus 9. So if r to r, fx is x square plus 2x plus say 4. Can you tell me what is the minimum value of this function?
4.
Is it?
No, sir, not 4.
Then Can I write this function as this? Can I write this function as this?
Yes.
Yes, sir.
Right? This portion, this square portion is always greater than equal to 0, right?
Yeah.
So the whole function should be always greater than equal to
3.
So minimum value will be
3.
Clear? What is the range of this function?
Greater than 3.
3 to infinity. Clear?
Yes.
Can you give another example, not quadratic equation, some kind of other example?
Mainly this type of equation will be coming. Okay,
Modulus.
quadratic type. Quadratic type. Modulus also.
Yes, modulus.
Right. So start with first mod x, just this thing. What is this function? What is the minimum value of this function?
0.
0, right? Because this is all positive number, right? How it works, you take any positive or negative number, it will give you the positive thing, right? This is the how the function works, right? What is the domain of this function? Domain. R. All real number I can take, right? What is range?
Positive number.
Positive real number.
So 0 to infinity, including 0. 0 can also be an output, right? So minimum value is 0, you can see, right? Is f injective?
So you can say n, right?
No. Why n? 1.5 you can get, right?
Yes, okay.
Then is f injective?
No.
No, sir.
Why?
-5 and 5.
Sir,
so if you take any negative number and any positive number, you will get same.
We're gonna get the same output.
Correct. So this type of situation arises.
We map for complex number, sir.
We are not dealing with complex number.
We don't discuss that question. Fifth question in activity questions 9.
Okay, I am coming to that. First, tell me, is it subjective?
May I just ask something?
Sir.
Have all the practice questions been discussed? Practice assignments?
I have not discussed any practice assignment here.
Sir, because actually I'm having many doubts with that. So, is there any video resource available to refer to?
So, first of all, practice solution is already there. Can you just go through that? And if further you have doubt, then you can ask me.
Sir, how can I access practice solution, sir?
It is in the portal, right?
Sir, can you give an equation value, sir?
It is not in the portal?
Yes, sir, it is in the portal.
Supplementary content, I think it is practice solution. You can go here and you can download the solutions here.
No, sir.
Sir.
Sir, it's not showing anything.
Okay.
Is it? 1 minute, let me check this one. Yeah, it is there.
Okay.
Okay, thank you very much, sir.
First check and then tell it is not showing. No? Yeah, so you can check it, and if further you have doubt, we have many sessions, right? Office hours, live session, 5 live sessions, you can come and ask. Okay, first
Sir, can you give an example for an equation maximum value, other than infinity?
I can give. First tell me, is it surjective or not?
No.
Not.
No, who asked that question? Yeah, tell me it is surjective or not. Is it surjective? What happened? What is the range? You have said that 0 to infinity, right? Codomain is whole R. Is two same? These two are same thing?
No, sir, not surjective.
Not surjective, right? Okay. You want some maximum value. Okay, fine. Fx, I mean, if you are okay with minimum, then there is nothing with maximum. So if I just invert this, minus x square, what will be the maximum value?
Well, why is it not surjective, sir? Because for every value in the range, there will be a value in the domain.
Is it -2? Can
-2
I get
cannot be in
-2
the
as an
range.
output?
No, but the range is only 0 to infinity.
That's why, no. For every value, I mean, range should be equal to codomain. It is not like that, right? Codomain is R
It's a
and range is
subset,
0
right?
to infinity.
Oh, codomain is R, okay.
Codomain is R. This is codomain.
So in this case, it's the subset, right?
Every case range is subset.
No. I mean, like in. Yeah. I got it.
This is domain.
Yeah.
Remember the picture. This is codomain. Range is in between that. If these two are equal, then we call it surjective. Okay? Clear, no?
Yes.
Okay. Fx equal to minus x square. What is the maximum value?
0.
So have you got an example where we can find maximum value? Right? Here we don't have any minimum value, right? It can go to minus infinity. So here
maximum is 0, sir. Maximum is 0, sir.
Yeah, it is minus, no? So here range is minus infinity to 0. Sorry, this should be open. This here range is this, right?
Yes.
Yeah, sir.
Clear, no? So we can have, these are basically inverted parabola, if you remember. In
yes,
second,
sir, yes,
third week you have that this thing. Okay? Clear?
Yes, sir.
Yes, sir, clear, sir.
Okay, great. Yeah, someone was asking about some activity question. Can you just tell me which one?
Yes,
I will
sir.
just solve one or two.
Okay, sir. Activity question number 9, fifth problem.
Activity question number 9. Activity 1.9. And first problem,
sir.
this one.
No, sir. Fifth problem said that injective mapping complex number.
Where you are saying complex number?
That this fifth one.
Where complex number is coming?
Under root 10 minus x. If x is greater than 10, it is going to be complex number, no, sir.
But that's why you have checked this is domain is given, no? So here you have to check when it is injective or not, right?
Yes.
But we do not have root of minus value, no, sir.
We don't need that. You have to check for domain only. So injectivity and surjectivity, when we are talking about, we are talking inside the domain. I mean, domain is already there. The function is defined. That what we have assumed. Now we are checking injectivity and surjectivity. Okay. The input we are taking, that is coming from domain. We don't need to go outside domain. Okay.
We should
so
not suppose
the first
output.
I'll explain that. So fx is root 10 minus x, right? So what is your domain?
Yes, sir.
What is your domain of x?
Domain of yes, greater than 0.
Greater than 0.
No, domain is
x
no,
for every
less,
fx belongs to R.
All real numbers.
less than
not
10.
all real number. Less
Sir,
than 10,
x for
right?
every fx belongs to R.
So 10 minus x should be greater than equal to 0, right? So x should be less than equal to 10. All such real number. All such real numbers such that x is less than equal to 10. Clear? So basically it's from minus infinity to 10. Right? This is your domain. So when you are checking injectivity, your inputs are coming from here only. Okay. So suppose I have two elements A and B, which are giving me same output. Can this happen?
No.
Are you sure?
Yes, it can happen.
Okay. So what is output for A?
Root over 10 minus A.
What is output for B?
Root over 10 minus B.
Now if I take square of this, what I will get?
A equal to B. Oh, sorry, 10 minus B.
Now 10 will cancel out. So minus A equal to minus B. That means A equal to B.
Yes, A is equal to B, sir.
So we cannot have two distinct outputs so that it will give me same input, right? So F is injective. Clear?
Clear, sir.
Yes, sir, clear.
Okay, fine. Now you can work out the rest 3, I think, yeah.
Sir,
the same thing.
Option 4, same question, option 4. How can we check if it is injective or not?
You cannot check it?
Option 4, sir. First 3 options I got. Fourth option I didn't get.
Okay, so let me write fourth option. Can you just repeat what the fourth option is so that I can write here?
Sir, f of x is equal to 5x plus 4 into 2x minus 3 divided by 2.
Okay. Okay, so first of all, whenever there are square function, right, there is a chance that it is not injective. Why is that? if you see square function for negative some number and some positive number, the value will be go to same. That is the idea. So if so can you give me two distinct input for which I am getting same output? Can you give me that?
Sir, 1
So suppose when this function is 0, can you tell me when the output is 0? When the output is 0, can you tell me?
When one of them is 0, or both of them is 0.
When one of them is 0, right?
Yes, sir.
So either this is 0 or this is 0, right?
Just 2.
So what is your x? Minus 4 by 4, 5 or 3 by 2?
3 by 2.
Now, if I tell what is f minus 4 by 5?
0.
0, right? What is f 3 by 2?
0.
0.
So two elements are going to same number, right? 0. So is it injective?
No, sir.
No, sir.
Is it clear?
Yes,
Yes.
sir.
Clear, no?
Yes,
Yes,
sir.
sir.
Okay, fine.
Sir, question number 6 also.
Question number 6. So today I think I have discussed all these problems. So I think you should try something. No? This I have discussed right now. So here it is from z to z, only integer to integer, not the whole real number. So for which of the following values this function is given function is bijective. So you should check it. I think I will suggest you check it once and then I will discuss it next day. Okay.
Okay, sir.
So you try it once because today I think is it clear what injective, bijective, surjective, all these things are?
Yes, sir.
Sir, we all tried.
Yes.
Yeah, you try. That's the main thing. You try and again we can discuss. No issue.
Yes, sir.
Okay, but at least concept are clear. What I have discussed today.
Yes, sir. Concept.
Yes, sir.
Yeah.
Okay. Yeah.
Yes.
Okay. So I
Sir.
mean, yeah.
Sir, I feel I may not be correct, but in graded assignment, the question 5 answer can be given in a numerical. There is a blank. We have to put the figure. But
Yeah,
I feel for that question answer is a bigger thing. Like it's a full set. So.
Oh, you are saying it is not a numerical thing, is it?
It's
Let's
something.
see. Which question?
less
Which
than-
question?
Question 5.
No,
I
they
may
have
not be
asked
correct,
for
sir.
cardinality of the set.
Correct, sir. So
how many elements are there? So
correct,
here,
sir.
what say? First, follow this. A be the.
So.
One minute. So here, what is said that let A be the set of integers which are not in the domain. Right? There are some integers which are not in the domain. Only those integers we need, and then that is your set A. What is the cardinality of that set? That is the question. First of all, you find the domain, right? Now, which is not in the domain, those integers which are not in the domain, you have to find only those integers. That will form a set. And the number of elements in that set you have to put there.
Sir, 1.11 second one.
Correct, sir. I felt key all the integers. Okay.
You need to put the cardinality only. What is the cardinality?
Understood,
It
sir.
is a
So
finite set. It is a finite number. I can assure you.
Okay. You are sure that
It is
it's a finite number, sir, right?
Yeah, I am assuring you. And I am
Single
also
digit.
assuring you it is less than 10.
Understood.
It's less than 10.
Okay, sir.
Okay, you just try it. Today we have seen, right? We have seen how to
Understood,
calculate a domain. Just
Sir,
try
understood,
it.
sir.
Yeah.
1.1 second. 1.1 second.
Coming. Yeah, you finish it. What?
No, I just wanted to say, sir, if we get across such problems, I know such will not be the case, but whom should we report such issues, sir, in case like answer is asked in numerals, but we found some other answer or something?
You will not find, I think.
Okay, sir. Okay.
Yeah.
Sir, from the same set, fourth, second.
This
it's
is
not
graded
even-
assignment. I will not discuss this.
Sir, 1.11. 1.11.
First of all, I said that I will not discuss it, but I have already discussed this problem in the live session. Same type of problem. Right? You just visit the live sessions once. I will anyway upload this note, what we have discussed today. So you will get it. Yeah, 1.11 what?
And
Which one? Second one. Minimum value of this function and the maximum value of this function is
Sixth one.
this. Coming to that. So what is the minimum value of the first function? You tell me. 9x minus 8. Can you tell me?
So it must be 2.
I am writing it. 1 minute. It is 9 mod x minus 8. What is the minimum value?
1.
So what is the minimum value for mod x?
0.
0.
For this, minimum value for this is 0. So what is the minimum value for this portion?
Minus 8.
No, for only the first portion. What is the minimum value?
0.
0, right?
0.
Min value for 9s. So this is clear to you? Right? Now what is the minimum value for whole thing? So this portion minimum value is 0. Now what is the minimum value of the whole thing?
Minus 8.
Minus 8, right? Is it clear?
Yes, sir.
Yes, sir.
Now I will ask you to find the minimum value, the maximum value of the second one and do the product. Will you do that?
Yes, sir.
Clear, no? How we can find it? You start with the basic thing, what you know, then go deeper with the operations.
So,
okay?
So mod x.
Question.
Yeah, 1 minute. I'll let him finish. Yeah.
Sir, can you do maximum also?
You are not doing, right? Okay. What is? But it will not help you. That I can tell. Gx is 11 minus x plus 8, right?
Yes.
11 minus x plus 8. What is minimum maximum value for x plus 8? Sorry, what is minimum value for x plus 8?
So 0.
Minimum value of x.
Yeah, what is the minimum value of this? Can you tell me what is the minimum value of this?
8.
0.
8, sir.
8 or 0?
Like if we put
8
for x. 8, sir.
So, yeah, 1 minute. So you are saying, 1 minute. So you are saying we cannot get any value which is less than 8. Is it? What happens if we put minus 8?
Yes, sir.
0.
0, right? So we can get 0, right?
That's 3.
So minimum value of mod, whatever mod we are getting, this is 0.
Yes.
Right? So this is minimum value. Now, this portion has minimum value. So minus of that will give me maximum value, right?
Yes.
What is the maximum value of this?
11.
11.
No, first this portion. The maximum value is 0, right?
0.
Yes, sir.
Now, what is the maximum value of the whole thing?
11.
11.
Is it clear to you?
Yes, sir.
Yes, sir.
Sir.
11.
Sir,
So this is the maximum value. This is the minimum value. Can you find the product?
Yes, sir. Minus 88.
Minus 8.
Thank you, sir.
Yeah. But you should do
sir,
it. No, you
just
should
a
try
question.
it.
Sir,
Yeah.
from next time.
Sir, just a small question about that part. So mod x plus 8 equals to 0, you have defined that. So what if we just put the mod up and just just define x equals to minus 8? I mean, for that input, so we can get the same value, right? I mean, for minus 8, the entire value is 0. So so can we just put? I mean, can we just use that logic for any other functions which are defined like this?
Yeah, any mod value, whenever you are taking some mod of x plus a, this is always, the minimum value is always 0, right? Because you can put minus a, so 0, but negative you cannot get, right?
No,
That
sir,
is the idea.
What I'm trying to say, I mean, for the feeding for the input, if we just assume x plus 8 equals to 0 and take x equals to minus 8, so that means we are getting the g of x, I mean g of minus 8, we are getting the maximum value, right? Because the entire part is getting 0.
Right.
So that's what I'm trying to say. In this case, we are doing that. So for similar kind of functions, we can just take that mod value or something, whatever inside that, and make it 0 and just get the input value.
Exactly. That is what I am doing. Exactly.
Okay.
That's what I am doing. You can see. That's what I am just writing.
Yeah. Okay.
Yeah. Okay. So
Sir, one question. So this y is equal to mx plus c. So there is some operation on x. So these are functions. But what about y greater than x? Because these are mentioned as filters in a lot of problems, relations.
Yeah.
So y greater than x or some other equation greater than something. Are these functions? Like
I mean,
comparative
what is the
functions?
function there? You have to define that, right? I mean, if I just say fx equal to all x which is greater than a, that is not a function, because then it will give a lot of number, right? Output is a huge thing. That cannot be a function, right?
Okay.
I don't know from which perspective you are asking this. Can you mention some questions so that?
It's in some activities, right? Forgot, but
Because I can define it in such a way that it will become a function, but I am sure that is not in the course. But still, what are you asking?
Okay. No, a relation is mentioned, sir, and in the filter section, y is
Can you
greater
give
than
me an
so and so.
example? Can you give me an example?
No, sir. But can that statement be treated? Can that relation be
Relation?
treated as
It can
function?
be. I mean, yeah, definitely. It can be a relation, because for
Yes.
relation it can go to anything, right?
Correct.
One input can give
there
me
is a similar
various
question in the
output.
graded assignment.
That's okay, fine. But I am saying that relation, it can be a relation, because relation, I mean, one element can go to very different places, right?
Okay, sir.
It does not matter. I mean, if you are asking a comma b such that a greater than equal to b, this is a relation. This is a relation, right? Are you there? Am I audible?
Yes,
Yes,
sir.
sir.
Audible. Sorry, sir. I was on mute. I said yes. Okay.
Okay, so this is a relation, right?
Okay, sir.
Can you tell me, is it reflexive? Is R reflexive?
Yes.
No.
No, sir.
No, yes, it can be.
Yes, sir.
It is reflexive. A
Yes,
is greater than
it
equal
is.
to A, because equality is there. So A comma A is inside R. That is true. Okay, so it is yes.
No, but that's just one pair, no, sir?
For every A it is there, no? Take any real number. That is equal to itself, right? So all such pair, 1 comma 1, 2 comma 2, 1 by 2 comma 1 by 2, root 2 comma root 2, all such pair are inside this, right? Because that number is equal to itself.
Okay.
Yeah.
Sir, sixth question, sir. Can you discuss it? Activity 11, sixth question.
Activity 11, sixth question. Why don't you try that? Hey, try this. I have explained this type of question today, so I will ask you to try this. So once you are, I am giving you a hint. Once you are inside square root, that square root is whatever that is inside square root, that should be greater than 0. That is the first thing, right?
Yes, sir.
And if there are some denominator containing x, that denominator cannot be 0, but here there are no such thing. So you just only have to take what is inside square root, make it to greater than equal to 0 and solve for x. You can solve inequality, right?
Okay, sir. We'll try.
Is it your problem? I mean, have you forgot how to solve inequality? Then I can give you some example.
No, sir. We'll
So
try.
suppose take this one. Okay, I will not solve that one, but I will give you another example. Okay, so let's take this one, 4 minus x plus 5 by 3. Okay, let's try to find the domain of f. What you will do? Can you tell me? Are you there?
Yes, sir.
Yeah.
It should be
So
greater than or equal
whatever
to
it is inside the square root, it should be greater than equal to 0, right? So I will
Yes.
write this. This is greater than equal to 0. Correct?
Yes, sir.
So if I take it in this side, so 4 is greater than equal to x plus 5 by 3. Right?
Yes, sir.
Okay. Now what I can do? I can take 3 this side. So 12 is greater than equal to x plus 5. Correct?
Yes, sir.
I can take 5 on this side. So 12 minus 5 is less than equal to, sorry, greater than equal to x. Correct?
Yes, sir.
So 7. 7 is greater than equal to x. So this is your solution. X is less than equal to 7. So domain of the function is all such x such that x is less than equal to 7, right?
Yes, sir.
So what is this set? This is basically less than equal to 7. So minus infinity to 7, including 7. Is it clear?
Yes, sir. Got it, sir.
Now can you try that?
Yes, sir. Sure, sir.
That is exactly same
Thank you,
type
sir.
of problem. Okay. Yeah. Great.
Thank you.
Okay. So I think we should stop this session now because
Yes.
it's already more than 3 hours.
Yes,
I hope it helped some of you probably. Right?
Yeah, it was very helpful.
Yes, sir. No, great session,
Thank
sir.
you, sir.
Very small doubts you have
Thank you,
sorted out, sir.
Yeah.
Yes, sir.
Okay. So
Thank you, sir. Good night.
yeah. Good night.
Good night, sir.
Thank you.
So you record all these things, sir, right, sir?
I will upload this note anyway, and this is in YouTube. This will be in YouTube. This is live stream. Okay.
Where can we get the notes from?
Thank you, sir.
There will be a folder where all live session slides will be there in supplementary content in your portal.
Okay, sir. Okay. Thank you.
There will be a section called live session notes, live session. So there you will get. Okay.
Okay, sir.
Okay. Bye.
Good night.
Yeah.
Thank you, sir. Bye.
Yeah. Bye. Bye. Bye.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Yeah. Thank you. Bye.
Thank you, sir. Good night.